Good evening and welcome to Aussienaut Live. G'day, I'm Josh Keegan. I am the host of Aussienaut Live and welcome to this IFT 5, the integrated flight test of the SpaceX Starship and Super Heavy booster. Welcome, it's good to have you along as always, and thank you very much for joining me for this particular historic SpaceX event. There's going to be a number of different things happening this evening where the SpaceX will attempt to launch their Starship again, and this time they'll try and recover the Super Heavy booster. They'll catch it on their tower, so it'll come back to the launch tower. So again, welcome to everyone. Just remember the questions and answers are open, so if you want to ask some questions, please pose your questions and answers now, so that way I can get to them and respond in a timely manner. They're all here somewhere. I'll just go find them all. So hi guys, yes, and it's a different camera as well, so it's just over here. So yes, Dean Tiernan. So welcome, Dean. Thank you very much for coming along. Good to have you again. I have seen you here before. Yes, it is going to be a long day, especially if you were actually up since 5 a.m. this morning for Bathurst. So in Australia, there is a thing called it's still the Bathurst 1000. It is Bathurst, and what they do is they run cars for around about 1,000 kilometres, so Bathurst 1000. So it is quite an extensive and long race, and it's been running in Australia since the late 1980s. So there you go, a little bit of Australian history for you right there. Looking at the wrong camera. It's a new setup. So I actually have two cameras. I have one there and I have one over here. So that way I can actually look at the questions and answers as we go through them. G'day, Jim. Nice to have you back. Always good to have your support, mate, here on Aussienaut. Thank you very much once again for joining the channel. It's always great to have you along and support my live streams and everything else that I do. I do actually greatly appreciate it, mate, as always. All right, so just remember the questions and answers are open. Please, if you want to ask a question like Jim, don't forget to join the Space Fam family. Come along, introduce yourself, say who you are, what you do, and remember that we are all one Space Fam. It's great to have everyone here from different corners of the globe because I do know I have a wide global audience. So let's press right along. So what we're looking at doing is I'm looking at covering the Starship, which you can see there on the little picture. There. Okay, there it is. So yes, and I'll move it over to the larger second screen so that way we can all have a good look when it actually starts to go live. Now, just a moment. What have I done to myself? Okay, just being technical. Here we go. There we go. So that looks a little bit better. It looks a little bit more borderless. So that way you guys can actually see the launch when it gets started. So just keep in mind that this is not due for another half an hour. So what I'll get to do is I'll get to give you a little bit of an insight and background into what Starship is all about, what they're trying to do, all that sort of stuff. I'm not as prepared as what I should be. I'll admit that right now. And no, I'm unable to get close-ups and all that sort of stuff of the Starship and the Starship launch. If you want to go and see that, please go and see Everyday Astronaut. Everyday Astronaut is one of those ones who will actually have up close cameras for you to see it. Please go and join those guys if you don't want to sit here and watch this Aussie yak on about potential things without actually getting into it. There's also NASA Space Flight as well. They are also doing this in addition to the Everyday Astronaut. And if you want to go and have a look at some Australian-based content creators, there is also I can't remember his name. It's gone. Yes, there's nothing like me being myself and forgetting people's names when I'm Astro Animator. That's it, Astro Animator VFX. A gentleman from Brazil. I actually he's in South Australia. He's communicating now with his Brazilian audience, and he's bringing this as well, the Starship live. So just here you can see on the screen there, just while I've got it up, that is the Starship, and that's the underside of the Starship with the heat shield. So IFT forward managed to achieve quite a number of successful outcomes from what it was doing. And part of that was actually being able to return. So the Starship did launch, the Super Heavy booster did come back. did actually manage to fire its the landing of the Super Heavy booster happened in the ocean. Then there was the re-entry of Starship at orbital velocities, testing atmospheric pressure on the tiles around the control fins, which was the main part of it. And as some of the footage we saw previously on the live stream, if you want to go and have a look at that, yes, it actually burnt a lot away, but the whole thing survived. So it was a very, very monumentous occasion. And there was also continuous footage of the launch and landings using Starlink. So that was something unique that I have never seen before. And I was very, very impressed by having the ability to see that and to share it with you guys. Again, as I said, this is not going to be the best. I'm restreaming everything that I'm getting through, which will be the SpaceX stream when it gets going, when it gets up and running. So yes, please feel free to go off and look at Everyday Astronaut, NASA Space Flight, or if you want to hear everything in Spanish, then please go and see Astro Animator of VFX, which is Cristiano Bandeo, and he has been joined me on a live stream before, and he is a very good one to watch. So, all right, so just going to yak on a little bit until we get to that point where we'll start to hear transmissions coming through from SpaceX. So it's not due to happen until 9:35 local time. So we've got a little bit of time before that happens. Again, if you want to go and watch someone else, please feel free to do so. I will not be offended in the slightest. All right. Just remember that chat is still open. There is merchandise available, all that sort of stuff, where you can go and get things like this. Yes, I have my caffeinated beverage, and it's ready to go. It's the 1967 Resat mug that is I managed to go through and recreate because this symbol has never been seen. But it was on the Resat satellite launched in 1967. That was Australia's first attempt at launching a satellite into low Earth orbit. And I, with permission from the Australian Department of Defence, I went through and created this mug, which you'll see on many of my live streams because it's holding my caffeinated beverage. All right, probably a rude thing to do on a live stream, but yes, I'm normal. I'm usual. All right, just in case anyone is wondering what I'm currently wearing at the moment, I've decided to, hang on, come back a bit. Whoa, there we go. I've decided to represent Southern Launch and the Coniba test range. I found this when I was cleaning up around the house today. I found this laying around, so I thought I'd just represent as Southern Launch. Southern Launch, if you want to go and have a look at that live stream, I went to South Australia in May and I managed to live stream a rocket launch. That was me by myself. What I managed to do is go and live stream the high impulse launch, the SR-75. That's a paraffin and liquid oxygen rocket by a German company called High Impulse. I went and managed to live stream that back in May and brought it to you, the audience here on YouTube, and I was very proud to do so. And I continue to do these things as always. Again, as I said, I'm a little bit unprepared for this. As always, I've tried to be as prepared as I possibly can, but when you start to get into things, all things SpaceX and Starship, then what happens is I found that there is a lot of information. So hopefully this is relevant and it's a little bit interesting and it's a little bit entertaining. All right, so we're just going to get into a little bit about Starship. So with Starship, it is ready to go. As you can see, these are some of the latest images that I managed to get from SpaceX. As you can see, it's sitting on its pad, and these are some of the distance vision. A couple of days ago, this new Starship was mated to the Super Heavy booster, and that has happened only just recently. So that's only happened in the last few days. And as you can see, it is more than ready to launch. Just some of the highlights, coming back to the IFT-4 launch, coming back to that one specifically. With the IFT-4 launch, the other things that managed to do was they also managed to do a hot staging. Hot staging is where the Starship started its engines while the booster was still running. And part of the footage that was on the previous live stream that I did actually graphically showed that very, very close. They had very close images of that. With that, they with the Starship booster, they did have a hot staging ring to actually protect the booster when the Starship engines were fired up. What happened with that booster, with that ring, was it was jettisoned away because it's unnecessary dry mass. So what they're looking to do this time is they're looking to possibly bring the booster back, and I'll get into that in just a second. They did the hot stage jettison. They managed to the booster landing, burn and shut down on splashdown. The Starship engine was cut off. Also, the Starship engines were able to be relit. They did a re-entry from the Starship. The Starship was able to do its landing flip, its landing burn, and it was able to splash down in the Pacific Ocean off the coast of Western Australia, a few thousand kilometres, but it's still towards Australia. So it managed to do almost a full loop of the planet and splash down off the West Australian coast. All right, some statistics about the good old Starship. Starship is... Yes, I am reading this because I did have a lot to prepare. Hang on, where's my Starship? Oh, what have I done? Oop. There we go. So just about Starship. So Starship is approximately 50 meters in height, or 160 feet. The wingspan that it has is about 17 meters. So it's a size, wingspan is 17 meters. So it's quite a massive wingspan. That includes the internal 9 meter diameter. The diameter is obviously 9 meters, and then with the wingspan, it's 17 meters. Launch mass at the point where it's going to launch is 1.3 million kilos, or around about 2.9 million pounds. So that's quite a significant weight. The dry mass is 100,000 kilos of the actual Starship. Payload capacity is 200,000 kilos. That's planned at the moment, or 220,000 pounds. The payload, crew capacity is looking to put 100 people in this, and the volume is 1,000 cubic meters, or 35,000 cubic feet, and that is what's planned. So the cutaway you can see there of Starship, it is quite a massive vehicle. Inside there as well, because it's Starship and SpaceX and everything related Elon, or Elon related, what's happened is he's managed to use some parts and components from a Tesla. So what you'll find is the wings that are manipulated and moved up and down. What happens with those wings is when they are moved up and down, they are powered by Tesla motors. So that's why they're able to get quite a bit of torque out of those motors. They're able to move the flaps up and down quite quickly and quite successfully. All right. Moving right along. So the Starship booster, as I said, it would landed in the Pacific Ocean off the coast of Western Australia, and this is an image that... Oh, we're on a break. What? Oh, okay. Let me get rid of that credit. Let me remove that credit. There we go. That's better. So that was the image that I managed to find from SpaceX. I'll just move it over there a little bit. And I'll put me behind it. There we go. All right, that's a bit better. So you only see the corner of my face. No, I'll put that back. So they went fishing for the Starship booster, and this is what was remaining of the Starship booster when they managed to recover it from the Pacific Ocean. Now, remember, the first time they did this in IFT4, it successfully went subsonic, transonic, subsonic, and then it managed to do a soft landing in the Gulf of Mexico. Gulf of Mexico or Pacific Ocean? One of the two. And what happened with that is because it managed to do a soft landing, this is why most of the 33 Raptor engines were intact at that particular point in time. So they managed to recover those, and they've brought them back to shore as far as I'm aware. All right, getting to questions and answers because they're starting to flow through, which is lovely to see. We'll go back to Jim. So, yeah, I'm just going to freely interrupt my own live stream to actually bring you the questions and answers because I like to have participation from everyone that's with me. So thanks for that, guys. All right, Jim, if this all goes the way we hope, it's going to be spectacular. Oh, yeah, I did get very, very excited during the last live stream, I will admit. It did actually take me, I did get very tongue-tied and very stunned, and I forgot that I was live streaming at certain points where I was just embarrassing myself, which was great because I was so fascinated at being a space fan myself. So yeah, just keep that in mind that I'm also a space fan. So if I forget occasionally during this live stream that I'm live streaming, then yes, please don't forget to let me know, prompt me in some of the codes. Good morning, Aussienaut, reporting from Huntsville, Alabama, US and Oh, well, thank you very much, Joe Blow. Thank you very much, and good morning to you, sir. It's a good evening here. It's around about 20 past 9 in the evening. That's in Eastern Australian time. Standard time, Eastern Australian summertime is started, so it means that the rest of the country is out of whack. Sydney is about an hour ahead, so is Melbourne. And the odd thing is that South Australia in Adelaide, they used to be half an hour behind. Now they're half an hour ahead. Anyway, so yes, welcome to the time zones of Australia. So and good morning again to you, Sir Joe Blow, and welcome to the Alabama US Space and Rocket Center. So thank you very much for joining us. All right, what's the comparison? Oh, Jim, always with a good question, mate. Thank you very much. What's the comparison between Starship and the Saturn V launch vehicle? So the comparison between those two, I don't have a graphic for that, which is why I feel like I'm grossly underprepared, is the Starship is taller and it is wider than the Saturn V. And for pound in terms of thrust and thrust vectoring and all that sort of stuff, the Starship outclasses the Saturn V. I can't quite remember what the forces are with those, so I apologise for that, not knowing that immediately off the top of my head. All right, so that was that. So in the last, thank you very much again for asking those questions. Thank you very much for being part of this. Again, if you could, if you want to keep chatting, yes, I will interrupt my own live stream to make sure that everybody is able to ask their questions, as many questions as you like, and as soon as they come in, I will possibly put them on screen. So please ask away. Just having a look around, just seeing if there's any change with the SpaceX broadcast. Let me just see. That's annoying. Yes, it's been back now by 10 minutes. It's now 9:45 p.m. That's local time here in Australia, which is about 7 a.m. So Joe Blow, please, if you want to have let me know what time it is currently in Huntsville, Alabama. Hang on, I might look that up myself. Okay, time now. Huntsville, Alabama. It is 6:21. Oh, dude, you're up really early. Thank you very much for joining me. I appreciate that for all the way from the United States. You do have better options. Just let me know if you need to know what they are, and I'll happily tell you what the better options are for you to watch it locally or stream it locally. And thank you very much. I do appreciate you joining me here, though, with all this sort of stuff. It is, again, very, very much appreciated, guys. And yeah, if you want to help me out with this sort of stuff, or you want to help support or sponsor me, just remember there is a Patreon page. If you want to go and support me on Patreon, I've placed that in the chat group. And then if you want to come along and sponsor me, there's a separate way to come along and sponsor me as well. Let me just go back and check the chat. Let me just go back and check the live stream. Ooh, looking good. Ooh, don't like that angle. Ah, dear. I entertain myself. All right, so 12:21 in Scotland. Thank you very much for that, Jim. I'll just put that right up. 12:21 p.m. in Scotland, so 12:22 now. All right, so yes, a great way for you to spend your Sunday afternoon watching me. Anyway, self-depreciating wit. So sorry, I keep forgetting there's a camera there and there's a camera there. I keep forgetting which one of the questions and answers are on. So yeah, I'll get there in the end, hopefully. Yes, so nothing further has happened. I've 9:45, so it's about 9:45, which makes it around about 20 minutes away, 23 minutes away from now, before SpaceX is due to start their live stream. Okay, you're going to see. Looking at the Saturn V now in front of Space Camp. Oh, Joe, way to get me right here, buddy. Oh boy. Jealous? Yeah, I'm jealous. Yeah, I'm totally jealous. I'm totally jealous. Oh, you have to see if you can. I'm not sure if they accept pictures in the chat or not, but oh, I'd love to see pictures of that and you standing in front of that and gloating. I'd love to see that. Oh, you've got no idea how happy that would make someone like me, being able to see that sort of stuff and seeing someone who's part of my live stream share those pictures, they're pictures and images. Okay, so for anybody who's keeps wondering what I'm doing, I have two cameras now. I've upgraded a lot. I've got one over here, which is straight in front of me, and then I've got the other one, which is over here. So I've actually tried to improve the way I present things and live stream things. So yes, now I have two cameras, and I catch myself out. So, oh, son of a Apollo NASA, remembering Grissom White, and oh yes, dude, absolutely yes, and. Son of Apollo mission NASA engineer, remembering Grissom White and Chaffee, I think, Apollo 1, RIP, guys. Yes, absolutely, RIP. And at the moment, yes, it's an historical occasion as well for SpaceX trying to do all the crazy things they're going to do. And I really, really hope that SpaceX manages to do it. All right, before we go too much further, I've just keep checking the time and making sure that everything's lined up, making sure everything's happening. Yes, Jim, without a doubt, the Saturn V is a beautiful ship. So just thought I'd let you guys know that the Starship has been tested, and the testing only happened just recently in September. Let's have a look. So yeah, and the test fire was completely. It worked well. Everything was green with the test firing, so that actually laid the way and laid forth the ability for SpaceX to do this launch this morning or this evening Australian time. Whoops, hang on, there it is. Oh, that was weird. Oh, that's what I heard. So yes, again, technical issues. All right, let me just say that the test fire, this is the test fire that happened a few days ago, a little while ago, and it actually laid plans and helped pave the way for today's launch. Absolutely amazing stuff to see. And yes, all the way from Australia. It was interesting to see that from this far away and only just recently too. And it was very, very interesting and very, very surprising. So yes, Starship is going to do some magnificent things. Now, I don't actually have any graphics for it. As I said, I've been unprepared. But as you can see, I'm just going to go to the biggest screen here. So this is Starship, and this is Starship on the Mechazilla. So the Mechazilla is a couple of arms that they've gone through and they hang the weight of the Starship on. So the unique thing that will happen today is not Starship, but Starship will in the future. The booster will return. SpaceX is attempting to capture that booster. So what they're looking to do is, instead of doing a soft landing in the ocean and destroying their engines, which you see here, what they're looking to do this time is they're looking to actually catch it on those two massive arms you see there at on the screen. So hang on, just let me fix that up so I can point at it. There we go. All right, so yes, so what they're going to do is they're going to use these two massive arms here to actually catch the booster. Now, the automatic thoughts would be from many people and many comments that I've seen about this is, what happens if they miss? What happens if it blows up? What happens if it doesn't work? Just remember that SpaceX actually has a second tower that is already under construction and almost complete. The only thing that is lacking is a pair of arms from Mechazilla, and so SpaceX actually has the ability to fail over if they need to. Now, keep in mind that in the last little while, SpaceX has actually launched a couple of times. So they've actually done Hoppy, they've actually done SN10, they've actually done a lot of them. A lot of them have actually gone through a RUD, so rapid unscheduled disassembly, and basically it's had very little impact on the launch facilities. It's only had minor worries and minor concerns with that. So the only concerns with that is basically go back to it, is the FAA. So the FAA has actually prevented this launch. SpaceX was supposed to get their launch license back in September. It was supposed to come through in November and allowing them to launch. So where are we? Oh, hang on, there it is. So the issues were with the FAA is that there was environmental complaints because SpaceX has chose to attempt a catch of the Super Heavy booster, which is what you see on over here, because they're looking to catch this part of this booster, the entire thing in its entirety when they return it. Now you got to remember that before you say, "Oh, SpaceX has had no experience in this," remember the Falcon 9. They launch and land that all the time with their booster. Their payload goes off and it goes through normal launch procedure, reaches the nominal orbits, all that sort of stuff. Even has had a couple of failures recently, and the payload has still been quite successful. There's been a few issues with the second stage. There's been a couple of issues with the booster. However, SpaceX has always been able to return certain things, or the payload has always been able to be recovered. But the payload has always managed to successfully make it to orbit, So in terms of this, what will happen is if this manages to blow up, and the unfortunate thing is, the reality is that might actually happen. Is if that happens, there is a second tower which is just off picture that SpaceX can then use as a failover point, so they can then continue with launching. Now, in terms of this whole Starship and booster, with all of these, how many are there? There's a lot. There's quite a lot of these left. So SpaceX is manufacturing these quite quickly. And if you go and have a look at the footage from Everyday Astronaut, where he has a tour with Elon Musk, Elon has gone through and given the Everyday Astronaut, Tim Dodd, a complete tour. They're looking to produce more engines, one Raptor engine every day, or three of them every day. They're quite a bit large cadence of Raptor engines coming through, same as with the Super Heavy booster. The Super Heavy booster is all made out of stainless steel, so that makes it a very unique mix. And with it being a stainless steel, what that does is it has very interesting properties for actually shedding heat and all that sort of stuff. And there's not much of a payload trade-off with going from something like a carbon fiber, which is really, really hard, and SpaceX was doing initially for the Starship. Elon decided that the payload difference was negligible when you're talking about those types of sizes, it was much easier to use stainless steel than it was to use carbon fiber. Now, this is a special type of stainless steel that SpaceX has come up with, and SpaceX, it's their own formula that they're currently using at the moment for the stainless steel for both Starship and the Super Heavy booster. All right. So just coming back to it, let me just see if there's any more questions and answers. So everything is clean on one side, guys, and everything is really quite busy on the other. I'm checking the SpaceX broadcast. I'm checking the questions and answers and all that sort of stuff. So it takes me a minute to come through, and I go, that's why I've got way too many screens and too many windows open. All right, and coming back is Joe Blow. Yes, it is huge in person. Each engine is enormous. Hello, Scotland. Oh, there you go, Joe. There you go, Jim. Joe was saying g'day, and hopefully, we get to see that. Joe Blow. Anyway, never mind. Just sort of someone I know in the Australian space industry that I haven't seen for a while. I was just thinking, that might be you. No, it's not. I don't think it is. But just in case it is, please let me know. Again, I forgot there's a second camera. Oh boy. Oh geez. I keep forgetting. I set this up. I made sure it was all happening. I did all this. Do you think I can get two brain cells to work together when I'm live streaming? No, I can't. Oh dear. Again, if you want to go and see someone who's slightly more professional than me, please go and go and see live stream the Everyday Astronaut or live stream NASA Spaceflight. Those guys are actually doing a very good job up close and personal, so you can actually see everything you need to see. Otherwise, if you don't like me and the way I'm ranting on, then you can go off and watch Astro Animator VFX, and that is Cristiano Bandeo. He's actually transmitting out if you want to see it in Spanish, so for your Brazilian audience. Just just also shout out in case he's watching. Tom June is my mate at UK Space News. He is a really good lad. He's a really good guy. And yeah, I have a lot of respect for Tom. So if you want to find out what's happening in the UK space industry, please go and have a look at UK Space News with Tom June. All right. Oh, look, I've got to take a break here. I am just going to, hopefully I get the one with the break. I'm going to take a quick break here for maybe a couple of minutes or so. We are looking at least 10 minutes, 10 or 11 minutes until the live stream with SpaceX gets started. I'm just going to take a break so that way I can have some water. I can stop chatting all in a row. I will be back to you very, very shortly. Please, again, as I said, introduce yourself to each other. Be nice, of course, we're all Space Fam. Thank you very much again for joining me, Josh Keegan, the host of Aussienaut. If you want to go and like and subscribe and all that sort of stuff to my YouTube channel, please feel free to do so. You're under no obligation to do so, but I'd love it. I'm going to watch this back and I'm going to cringe so hard. So please, while I go and take this break, I'll be back with you soon. Hopefully the broadcast will be started. I'll be gone for around about 2, maybe 3 minutes. But however, I'll be back with you very, very shortly. So please enjoy this break. Okay, try that again. Welcome back. Apologize for that one. Oh, God. Oh, I forgot to unmute myself. Okay, all right. Just having a look around. I haven't. There's having a look around. Yeah. So there's a bit of a delay. Just in case anybody didn't know, there's a bit of a delay between what happens live here and then what happens in the live stream. So when you do a live stream on YouTube, you get to talk. You talk here. You see it in your program over here. Then the live stream that comes out is delayed by about 7 seconds or so. So what happens is there are some times when you see the reactions where forget to unmute my microphone, those sorts of things, and make a bit of a faux pas and a mess of myself. So yeah, unfortunately, that's what's happened there. All right, so again, I'm back. Thank you very much for your patience. Thank you very much for coming back to this watch party. Thank you very much, everyone, for joining me. So to Joe, to Jim, and to Dean. I understand you're there, mate, somewhere. Although he may have gone to bed. He's been up since 5, so it might be a little bit too late for some people here in Australia. 5, which would have been 4 New South Wales time too, because they're an hour. No, they're an hour ahead, so it's 6. Yeah, it would have been 4. Would have been 4 here in Queensland. So yes, there is the daylight saving time that's in operation again at the moment. That's where all the states differ absolutely and completely. Meaning that it's very, very confusing when you're trying to call people into either interstate or internationally, because then, it gets really weird and really wild, but that's okay. All right, so yes, there's merchandise. I've said all that. You want to help, blah, 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 blah. Oh, okay, cool. Here we go. There's more stuff. All right, so 6:32 a.m. Central Time should be soon. Yes, it should be. So it is around about 3 minutes away before the live stream starts, whether or not that actually is the time that it actually launches, or they're still loading. Because I've done this before, it's actually the load of the methalox and the liquid oxygens. It takes a little while for that to happen. So please, keep in mind that they may not kick off right on time because it is space travel. It is launching a rocket, and when you launch a rocket, it is always hard. Again, when I was at the live streaming of the launch at the High Impulse launch in South Australia, I arrived on the Monday. It was supposed to launch on the Tuesday. It arrived on a Monday. We had a tour on the Monday, supposed to launch at 7 a.m. next morning, and got postponed from the Tuesday to the Friday, even on the Thursday night before it was due to launch. What happened was the winds were low, the skies were clearing, everything was working out. What happened was the Australian Space Agency needed to actually provide the launch license approval, and that happened when I was sitting in my motel room, not a hotel, motel room, because that's what they have out in country town, the little country town of Ceduna, which is around about 40 kilometres away from the Coonamble test range, that came through. So when I was sitting on Twitter, like you do, what happened was, the launch license approval came through. And yes, it was. I was very upset to begin with, and then I made a second post, which was slightly better than that. All right, hello, Huntsville. Oh, I've been lucky enough to visit the Kennedy Space Center twice during the shuttle era. Johnson. I'm assuming the Johnson Center back in 2014. Slightly very jealous that you can see the Saturn V whenever you like. Oh, hi, Josh. Dropping the audio. Oh, okay. Hang on. Okay, all right. How is it now, Jim? I know this is going to be a little while, but yes, as soon as you can, please, if you could please let me know whether or not if the audio is better or worse than what has been before. I have actually tried to do everything I can to make sure that this is working correctly. So yes, all right, cool. All right, let me just see. I'll refresh my screens. Okay, still 2 minutes away, so a little bit of time. Launching a rocket is rocket science. Yes, it is. It absolutely is. Yeah, weather and conditions are making sure it's okay. The winds have got to be low. The skies have got to be clear. The conditions need to be not perfect, but right. Even with the 7 a.m. launch time, in the end, instead of it being 7 a.m., it ended up to be 2 p.m. in the afternoon. So it was a little bit better than that. So all right, better now. Thank you, Jim. I appreciate it once again, mate, that you've managed to keep and listen out for me and make sure that my audio levels are fine and working well. I appreciate it as always. All right, let me just have a look around here. I'm just seeing if there's anything that's going to be starting anytime soon. Not yet. As soon as it does, I will switch across and I will make sure that I bring everything to you live, even with the commentary, the necessary commentary that will go along with it. So the other interesting thing about the IFT-5 is that, yes, even though it is going to be landing on Mechazilla, which is these magnificent arms here, the booster, not the Starship. The Starship will actually go back and do another orbital, not a complete orbit, but end up in the same spot once more. And it was due to actually do a flip and belly flop. So it will land, it will face its engines towards the ocean, and as it faces its engines towards the ocean to slow down, what will happen is it will then, once that happens, it will, as it gets closer, it will then go onto its belly and belly flop down into the ocean like it did once before. Hopefully this time they will actually get to do their orbital, their propellant transfer, which was part of IFT-4. IFT-4 was completely successful. Everything worked nominally. The transferring of fuel was one of the big ones that we didn't get any updates on. There was no further updates about whether or not that worked. So I'm assuming that will be part of what they're trying to do now. The other thing they did as well, which was IFT-3, was they actually had a door that they opened, and that was for the PEZ dispenser for when they are looking to shoot Starlink satellites outside of the Starship. I assume at some point that Starship will be used as soon as it manages to meet a few more parameters. The future for Starship is to start launching Starlink satellites to further build out the network that's currently being built. That's how I actually did my live stream. I did my live stream using a Starlink because if you want to know, the Coniber test range is actually in the Nullarbor Plain in South Australia. So that's in the middle of nowhere. And no internet, no Wi-Fi, no nothing. So I had to bring my own. There was internet and Wi-Fi and whatever there was of that, the very small satellite links that were actually being used by both High Impulse and Southern Launch. So I had to bring my own independent set, and that's where I have my Starlink, which is sitting right there, just off camera on that side. So yes, so there is a PEZ dispenser. They are looking to use Starship to build out the Starlink network, which will be quite a significant, bigger size of Starlink satellite that they're looking to put into low Earth orbit. The other intent for Starship, once it becomes successful and manages to meet a few more parameters, is that the Starship is due to land on the moon as part of the... so 9:47. Nothing's happening. I don't know what's happening. All right. Artemis is looking for the Artemis mission. I think it's Artemis 3. They're looking. Artemis 3 will do an orbit of the moon, and Artemis 4 is landing astronauts on the moon to begin establishing a lunar base, and that's what the Starship is intended to be used for. It will be a different version of the Starship that you see here on screen. The reason, what I've seen so far is it will be a very different version. Not so many Raptor engines. There are 3 vacuum optimized Raptor engines and three smaller Raptor engines. That's for maneuverability and landing for when it goes to land. So there are 3 vacuum optimized, and you should see them. They'll be quite large, and then 3 smaller ones which are made for atmospheric travel or made for landing back in the ocean here on Earth. As for what it will be on the moon, not quite sure about that yet, but I'm going to return to questions and answers right now and look to the right way. All right. Are they Lloyd Blue? Welcome, Lloyd. Thank you very much for joining me. Yes, they are going to try a catch. Absolutely, they're going to try and catch the Starship. Are using Mechazilla, which you can see the two arms there on screen on the smaller screen. Absolutely, they're going to give that a shot. If it blows up or it doesn't work, there is an actual second tower, and there are a lot more Starships and super heavy boosters ready to go. Because if you had a look at between IFT 4 and IFT 5, SpaceX wanted to go in. To launch in September or soon after, because the first IFT4 was in June. They wanted to launch in July or August, and there was another Starship and super heavy booster ready to go. They're saying it's not going to be a catch attempt. Okay, maybe I'm wrong. Could be. I don't know. The last I heard was that there's going to be a catch attempt, and of the super heavy booster, at least not the actual Starship, but the super heavy booster. The Starship will belly flop into the ocean and won't actually may not be recovered. So that will happen off the coast of Western Australia, which is close to where I am. Not close. It's about 5,000 kilometres from where I am, but. Anyway, so they must try to catch today, or the entire reason for the catch tower is moot. True. Good point, Joe. I understand that. It is absolutely moot. That may be something that they're unable to do, which is entirely possible. It is space flight after all. I'm just checking to see if there is. Okay, so prop load of the Super Heavy booster is underway, according to SpaceX's Twitter feed, and that was as of 2 minutes ago. So they're doing their prop load right now. So I'm assuming that they will have something they'll go live when they get more propellant on board and almost be ready to go. And yes, coming back to your question there, Joe, absolutely, it is a good idea to give it a try. Elon said that that's what they were going to do. I would assume that that's correct. I don't know. If Elon, but the thing is, though, is that if Elon usually says something and he says he's going to do something, he does it. Whereas I've seen other companies that try and say they're going to do something and haven't done anything just yet. I can give you specific examples here in Australia of companies with leaders who say they're going to do things and they haven't. And there is, again, at the moment, with the space industry being as hard as what it is, yes, there is a whole bunch of companies that littered the field, and even the majors as well, like Northrop Grumman, Lockheed Martin, ULA. They've all tried to do grandiose things in the past, and have had spectacular failures. And with ULA, they had a recent failure. Well, it wasn't failure, but the rocket nozzle dropped off. Their rocket, the Atlas V, I think it was. So the space is hard and it's uniquely hard, but the whole idea, of course, is to try, and SpaceX's philosophy is to fail fast and fail forward. All right, and learn from their mistakes. Oh, okay, we're about to go live. Give me a second here, guys. I'm going to swap my screens, make this larger, put this over here. Here we go. And we shall go to the second screen. Okay, again, I will rely on you guys to let me know whether or not we've got clear audio coming through, both of myself and the music that has been coming through from the SpaceX live feed. So we've managed to start here. So please, again, let me know if you managed to hear the live feed that's coming through nicely and whether or not you can hear myself. So I'll be quiet for just a second. Here we go. Oh, look at the pulsing of the atmosphere. Star hover. SM10. First successful landing. Amazing stuff. 30
It
minutes
is
to go.
6:54 a.m. in Starbase, Texas, a gorgeous sunrise, and Starship is targeting liftoff in just 30 minutes and 18
nice.
seconds from now at 7:25 a.m. Central Time. As you can see, it is a beautiful day in South Texas for the 5th flight test of Starship. Good morning, Star people. I'm Kate Tice.
And I'm Jesse Anderson, and we are joining you live from SpaceX Hawthorne with a big crowd here this morning. It's been roughly 4 months since our last Starship flight, and we've got a big morning ahead of us.
Flight 5, has a few primary objectives and one big first. We may be attempting to catch the Super Heavy booster. The teams at Starbase have been hard at work around the clock upgrading hardware across the entire tower with focus on the chopsticks, the 2 mechanical arms that will reach out and catch the returning booster. We're only going to attempt the catch if everything on the booster and tower checks out after launch, but either way, excitement is definitely guaranteed.
Definitely. Today's Starship features a completely reworked heat shield with stronger tiles and a secondary layer, which is an extra layer of protection for the ship that will protect from any of the that will help protect if there's any missing or damaged tiles. Now, not only did we replace the entire heat shield with our newest generation of stronger tiles for today's flight, we'll also be flying a handful of aluminum tiles that are there to help the team understand the thermodynamic environment during re-entry. If you were with us for Flight 4, you'll know how hard those heat shield tiles worked during the ship's re-entry.
Yeah. Did they ever? As you can see there, they worked incredibly hard. This big heat shield rework that we're talking about promises to increase the likelihood of Starship being better protected during controlled re-entry as it heads towards its flip maneuver and landing burn for a soft splashdown on target in the Indian Ocean, just like we did in Flight 4. And we'll have to wait and see. Keep your fingers crossed, but we may have some new views in store for you today as well.
Right, like all test flights, we want to learn as much as possible, and views of Starship during all phases of flight help us to keep improving the vehicle for recovery and reuse.
Now, thinking forward to when Starship is flying regularly, it will take the heaviest payloads to space, land humans on the moon again after more than half a century, and ultimately fly people further into space than ever before. And getting there will require us to rapidly iterate and fly often, which is why we're working so hard to scale operations at Starbase.
Yeah, the faster that we learn now, the faster we can improve and evolve Starship to achieve reliable flights and rapid reusability. We've been designing this vehicle from day one to realize a vision of having an entire city of people on Mars, something we know will take launching millions of pounds of cargo and equipment into space spread across thousands of flights.
Wow.
This future will require many Starships that can fly again and again, and today's flight is a critical step on that path.
So buckle up your seatbelts because here we go. The moon and Mars are not nearly as far in the future as you may think. In fact, we're planning to send Starships to Mars as soon as 2026.
You might be familiar with the Starlink logo, and there you can see it on your screen. It's an iconic representation of the Mars transfer orbit, also called the Hohmann transfer orbit. This is how fundamental Mars is to SpaceX. This transfer window, or a time when the Earth and Mars are the closest to each other, opens every 26 months and is only open for about 2 to 3 months at a time for a vehicle with Starship's power. And it just so happens that the next Mars transfer window opens in 2 years towards the end of 2026.
Yeah, lining up a launch to Mars is similar to how we launched to the International Space Station, where we time launches to match the station's orbit. If we didn't do this, we'd need more propellant and more time to get there.
Exactly. So the first opportunity that we have to fly Starships to Mars, we plan on doing it. These first flights to Mars will be uncrewed and will test the reliability of landing intact. If those landings go well, the first crewed flights will follow soon after.
So it's safe to say it's all happening, and flights like today's are what's going to get us there. Not only have we made several improvements to the Starship flying today based on what we've learned from our last flight, including extensive upgrades to Starship's hardware and software, we've also made improvements to the launch tower and catch mechanisms.
And if you've noticed in some of the live views this morning, our teams have completed stacking the second launch tower, which will be coming online next year. Having 2 operational launch towers paired with ships and boosters rolling off the line in our new Star Factory will allow us to increase our flight cadence and test even more rapidly. And just a few miles away from the 2 towers, things are moving really fast at the heart of Starbase. Star Factory is rapidly coming online, with production teams already using the space as construction continues. The 1 million square foot Star Factory brings many parts of the manufacturing process under one roof for the first time, enabling moving as much system integration work as possible earlier in the build process, with the goal of eventually producing hundreds of Starships a year.
That's crazy. It's such an impressive building. So, for example, teams can assemble an entire nose cone structure of a ship into a single piece and work on its internal systems all in one place. So if you're working on Starship and you have a question about the steps that you're working that happen before or after yours, instead of having to leave the building and go and find the person or the team with the answer, or waste time sending an email and waiting for their response, odds are you're right next to that person or team, and now you're working right alongside them, so you don't have to wait for a response.
Yeah, exactly. It makes it a lot more efficient and faster to communicate. So not only are we rapidly iterating on these spacecraft themselves, but we're also innovating the way that they're made.
It's almost too much to keep up with.
We're also posting updates on our account on X. If you can't keep up, that'll help you. So if you don't already, make sure that you follow us at SpaceX on X. And I have a feeling it's going to get pretty busy.
Oh, that is definitely an understatement.
And it's definitely going to be very exciting today. So with that, let's meet today's Starship on the pad. Starship features 2 major parts: the ship, which has 6 Raptor engines, and the Super Heavy booster, which has 33 Raptor engines. The current iteration of Starship is essentially an experimental vehicle flying for development. With a few planned upgrades, Starship will have 3 times the thrust of Saturn V, plus the added benefit of full reusability. Starship 2 will be capable of carrying more than 100 tons to orbit, and Starship 3 will be able to lift more than 200 tons to orbit. The amount of mass we're able to launch per rocket is crucial to creating a self-sustaining city on Mars.
Now, to get a sense of how big Starship is, let's start with the average size human, which is about 2 meters high. Towering over our average human is the length of the Millennium Falcon, which comes in at 35 meters. Our Falcon 9 rocket, with the payload fairing attached, is double the size of the Millennium Falcon, standing at 70 meters. And nearly twice the size of that is the fully integrated Starship at 121 meters tall. The ship itself is about 50 meters tall, and the Super Heavy booster alone stands about 71 meters. And even crazier, eventually the ship and booster will get even taller with future design iterations.
Can't imagine it being taller than that. Starship's first stage has a diameter of roughly 2.5 times that of Falcon 9, and with 33 much larger Raptor engines, which you can see there on your screen. Moving up the vehicle, the ship features 6 Raptors, 3 sea-level engines, and 3 vacuum engines, which are optimized to operate in the vacuum of space. The ship is designed for vertical takeoff and landing on any hard surface, like the surface of the moon. The ship is also outfitted with 4 flaps to help aerodynamically control the vehicle's attitude during atmospheric flight and enable a precision landing.
That's gorgeous.
To reach full reusability, the ship must survive entry not just once, but over and over again. It took the teams at SpaceX about 3 years to develop the heat shield on Starship, and development for improvements is still ongoing. The ship's heat shield is composed of 18,000 hexagonal ceramic tiles designed to insulate the vehicle during atmospheric entry, where temperatures can be as high as 2,600 degrees Fahrenheit. And naturally, the tiles are designed for rapid reuse with no refurbishment between flights. As we mentioned earlier, today's Starship features a completely reworked heat shield with stronger tiles and a secondary protective layer. This promises to increase our chances of Starship making it through a controlled re-entry, and hopefully a little more intact this time around. And in between our first and second stages is our hot stage, which we last saw in action on flights 2, 3, and 4. Speaking of, let's take a trip back in time and talk about that last flight. On June 6th, Starship successfully lifted off at 7:50 a.m. Central Time from Starbase, Texas, cleared the launch tower, and went on to accomplish several major milestones and firsts. As you can see there, Super Heavy booster lifted off successfully and completed a full duration ascent burn. I love the view of the sound waves there. Following separation, Super Heavy booster successfully completed its flip maneuver, boost back burn as well to send it toward the splashdown zone, and it also jettisoned the hot stage adapter, as you can see there. We don't have to jettison that adapter in future iterations because it'll be a different design. Now, as you can see here, the booster is returning back to Earth using those hypersonic grid fins to steer it towards a precise landing in the Gulf of Mexico. The footage that we have coming up here, there it is from the buoy. I still remember seeing this on X for the first time, and it was so incredible to see that booster coming down, ending its flight with a soft splashdown 7 minutes and 24 seconds into the flight, and the crowd went wild.
And so did we. Starship's 6 second-stage Raptor engine successfully powered the vehicle to space and placed it on a trajectory that would re-enter less than 1 orbit later over the Indian Ocean. And following a coast phase in space, Starship re-entered the Earth's atmosphere, successfully making it through the phases of peak heating and max aerodynamic pressure, and demonstrating the ability to control the vehicle using its flaps while descending through the atmosphere at hypersonic speeds.
It's hell,
and of course, Starlink on Starship once again enabled real-time telemetry and live high-definition video throughout every phase of entry, with external cameras providing views all the way to the flight's conclusion.
Flight 4 ended with Starship, with, again, the crowd going bonkers, with Starship igniting its 3 center Raptor engines and executing the first flip maneuver and landing burn that we had seen since our high-altitude campaign. And that was followed by a soft splashdown of the ship in the Indian Ocean 1 hour and 6 minutes later.
And we were all glued to the monitors watching the little flap that could the whole way down. Seeing the landing burn and splashdown was an incredible moment for the entire SpaceX team, and we'll be looking out for many more of these incredible moments today.
All right, so while today's mission profile is similar to Flight 4, we got a couple new test objectives, including catching the booster back at the launch tower.
In about 18 minutes from now, Super Heavy will ignite its 33 Raptor engines and lift off from Starbase. A little more than 2.5 minutes into flight, the Super Heavy booster will separate from the ship in a hot stage separation. After that separation, the booster will perform a flip maneuver followed by a boost back burn. And about 2 seconds after that burn ends, we'll jettison the booster's hot stage. As it heads back towards the ground, the booster will either attempt a landing, will have a landing burn, but then will either return to the tower or splashing down in the Gulf of Mexico.
Meanwhile, the ship's engines will remain lit for just under 6 minutes during its ascent phase before shutting down for the coast. The ship will coast for about 40 minutes or so, reaching a peak altitude of about 213 kilometers. After that coast phase, the ship will be attempting a controlled re-entry, including a flip maneuver and landing burn, like we saw on Flight 4, just before splashing down in the Indian Ocean. Now, we say attempting because, again, this is just a test and nothing is guaranteed.
Except excitement.
Well, of course there is that. Now, both the booster and ship have to contend with some extreme conditions on re-entry, which is where those heat shield tiles will be put to the test.
For this flight test, we do not expect to recover any hardware from the ship. With the exception of Falcon, this is no different than what happens to most rockets flying today that are expended, meaning that they fall into the ocean after completing their mission. Eventually, we will return and reuse Super Heavy boosters and Starships as we do today with Falcon 9 and Falcon Heavy boosters. And in fact, we've landed Falcon boosters 352 times to date.
Oh, man. I hear you say that number, and that is just wild. I still remember the night, or at least most of the night, that Falcon landed for the first time, and it still feels like yesterday.
I remember live streaming that
definitely
as well.
one of my favorite moments at SpaceX.
Well, live streaming,
and returning
watching the live
Super
stream.
Heavy promises to be an even more impressive sight and a huge moment on the road to rapid reusability.
Yeah, speaking of rapid reusability, future Starship designs will give Super Heavy boosters a lighter weight and integrated hot stage intended for full reusability, which will mitigate the need to jettison the hot stage like we'll do today. Similarly, even though ship recovery is not expected, the telemetry and data we receive all the way to the end is what we're what we're looking for, and is what will get us to a rapidly reusable Starship of the future.
Yeah, exactly. In other words, just like previous Starship flights, the payload for this mission is the data. All right. Now that we have a handle on today's flight test, let's check in with Dan, who is right in the middle of the action. He's just a few kilometers from Starship on the pad. How's it going, Dan?
It's going great, Jesse. Welcome back to Starbase, everybody. It's been far too long. Little change of scenery this time. Right behind me is the launch control
center.
Okay,
so while there's a change of scenery and all that sort of stuff, I'm going to flip to the questions and answers. It's still playing in the background. So thanks again, Jim, for asking the questions. I'm just going to turn him right down a little bit more. So there we go. So launch to Mars in 2026. You better get a suitcase out. Yeah, you better. It's going to be really soon. And Mark Rolfe, thank you very much for joining me on the Zoom experience that you had with the aerospace camp. That was really good. It was really good meeting everyone at those aerospace camps. It was really interesting. All right, and you subscribed, of course. So thank you. Do appreciate it, mate. Very much. And Jim, once more, the nice use of the Millennium Falcon for scale. What is Starship's parsec? Parsec? Yeah, how many parsecs is it going to be? Yeah, absolutely agree with you there, mate. I wonder what that's going to be at all. So, all right, well, we'll return to the live stream. We'll get back to that main second screen, so that way I'll be a little bit quiet. Looks like everything is go. The weather is go. The range is go. The vehicle is go. Everything is almost loaded. It's still loading at the moment. The wind temperature is 6 kilometers an hour, which is quite low, and the temperature is 76 degrees Fahrenheit, which is, let me just see, 76 degrees Fahrenheit. It's around about 24 degrees. So yes, I do have a converter on the other side. I am looking at that properly. I am making sure that I can actually convert them across.
Kind of in the last second, but if there's nothing holding us back, we're going to go right past that and go down to 0. So, I mean, as of right now, we're just under 14 minutes away from liftoff, not working any technical issues. Range is expected to clear. We're just clearing out a few more boats. And as you can see, the weather is perfect. We had 100% go for launch from the weather officer, so that was pretty unprecedented and something we really like to hear. If we're not able to go today, since we are loading prop, it would likely be about 48 hours before our next attempt. But good thing we're going to launch today. Really looking forward to being able to turn around and see it this time. Counting down to 7:25 a.m. Central, and I'll see you guys in a couple of minutes. I'll send it back to you in Hawthorne.
Thanks, Dan. Now, one of the most exciting objectives for Flight 5 today is attempting to return the booster to the launch site that you see right there, and it will be caught by the tower. We refer to this simply as booster catch.
As you've heard us say, Starship and Super Heavy are designed to be rapidly reused, which is why we've developed a novel way of returning the vehicles that leverages the same hardware we use for stacking ahead of flight.
Right now, when we recover our Falcon boosters, they either return to a separate landing zone on land or to a drone ship in the ocean, both of which require time to transport the vehicle back to the launch site. In order for us to achieve truly rapid reusability, we need a quicker turnaround, and you can't get much faster than returning the launch vehicle right back to the launch site where it needs to be in order to launch again.
For today's booster catch attempt, while there are thousands of criteria that need to be met, there are 3 primary gates that will be in play. In order to proceed, automated checks have to indicate we have a healthy booster and a healthy tower, and the flight director must issue a manual command, which is informed by manual checks from the flight control team. If this command is not sent prior to the completion of the boost back burn, or if automated health checks show unacceptable conditions with Super Heavy or the tower, the booster will default to a trajectory that takes it to a landing burn and soft splashdown in the Gulf of Mexico.
Now, thinking to the future when we're operational, after a booster returns to the launch tower, it will be inspected and reloaded with propellants and then ready to launch another ship to orbit. For today's test, however, we're only going to attempt the catch, like Jesse said, if everything on the booster and tower checks out after launch. And of course, we will let you know as soon as we know if it's a go. And we're going to be listening very keenly for that call out. Now, as always, we accept no compromises when it comes to the safety of the public and our team. So to that end, the area all around the pad and the flight path are cleared well in advance.
Exactly. A lot of things have to go right in order to line up the booster catch. So don't be surprised if we don't attempt the catch today. Either way, today's flight will generate data that will continue to inform our future flights and help us get to that operational cadence.
Yeah. Oh, you can't forget what else it will generate.
Are you thinking what I'm thinking?
I mean, I was going to say a sonic boom.
Oh, I was going to say excitement, but that's a really good reminder.
Now, if we do make it to a catch attempt today, Super Heavy may generate a sonic boom upon its return. And that's basically a brief thunder-like noise that we hear when an aircraft or other object travels faster than the speed of sound. Anyone that has been in the area for a Falcon 9 land landing in Florida or California, or even some space shuttle landings, may have heard one of these.
Generally, the only impact in those surrounding areas of a sonic boom is the brief noise, with variables like weather and distance impacting if or how the sonic boom is heard. Here's a brief look at how these sonic booms look and sound on Falcon.
I know a lot of people will be excited when they hear the sonic boom.
And these are going to provide quite a show because you're going to hear those sonic booms.
Sonic boom is great for us.
There's one thing I'd like to do, and that's I'd like to hear the sonic boom. That would be a magnificent. In person, I'd love to hear that.
Side booster separation confirmed.
Just heard the 2 sonic booms here in the room.
Booster landing confirmed.
As our test flights continue, we plan to demonstrate ship-to-ship propellant transfer, which will be important in preparation for Starship taking astronauts to the moon as part of NASA's Artemis program.
There it is. That's what I mentioned there before.
SpaceX will perform one uncrewed demonstration flight before NASA's Artemis 3 mission, which will be the first human surface expedition since 1972. Also, in preparation for missions to the moon and Mars, we're gaining tons of knowledge from our human spaceflight missions, including free flyer flights like our recent commercial astronaut mission, Polaris Dawn.
Polaris Dawn was the first of up to 3 missions in the Polaris program, which is demonstrating new technologies, conducting extensive research, and will culminate in a flight of Starship with humans on board.
After nearly 5 days in orbit, Dragon and the 4-person Polaris Dawn crew safely splashed down on September 15th off the coast of Florida, completing the first human spaceflight mission of the Polaris program.
A little bit better.
The Polaris Dawn crew performed some incredible firsts during their mission. Dragon and the crew reached 1,408.1 kilometers, the highest Earth orbit ever flown, and the farthest humans have been from our planet since the Apollo program.
The crew also performed the first ever commercial EVA, or extravehicular activity. And as you can see there, they were wearing the new EVA suits that we developed here in-house. This was an incredible moment to see Jared and then later Sarah emerge and perform this EVA with Earth behind. Now, in addition to this incredible spacewalk, they also conducted about 36 research studies and experiments from 31 partner institutions, including NASA. And in addition to all of that, they also tested Starlink laser-based communications in space. The data gathered from Polaris Dawn missions is invaluable, much like the data that we're going to see after today's flight test of Starship. So we're coming down to T-minus about 7 minutes. Let's check in with Dan.
Okay, here we go. 7 minutes.
Thanks, Kate. So yeah, we're right at about 7 minutes away from launch. The main thing we are still working is that range clear. Again, we have to make sure boats, airspace, everything is cleared out of the way for our ascent corridor, basically the Gulf of Mexico, where we're launching through before we can actually launch.
I keep blocking stuff.
So we're working on clearing out just a few more boats. We do have a window, remember. So if we end up holding it like a T-minus 40 seconds, we can hold for several minutes, allow those boats to get out of the way, and then we can launch. Our window is from 7 to 7:30 Central, so we don't have a huge amount of time today, but we do have some margin if we need to work with it to still get off the ground today. For now, though,
it's good though. Everything is go. So weather is go, range is go, vehicle is go. Wind is very low. It's dropped to kilometre per hour down to 5. The temperature is still sitting nice, and currently there is around about 1.2 million people watching this live stream,
20 seconds for the ship,
including us,
and then just 30 seconds later for booster. One kind of cool thing to talk about, so the folks in launch control behind me, after liftoff, they're going to have some pretty special tasks today if we're going to go through with the catch. They're going to be doing some really detailed inspections just visually of all of the different tower systems, a lot of those things that we upgraded, just to make sure that we are in the right posture to actually proceed with the catch. So they'll be working kind of fast and furious behind the scenes to inform the flight director's manual command to send the booster back. So if we hear that command being sent, that's going to be just the roof's going to come off. That's going to be a really exciting
I'll also be listening
moment.
for it as well. So yeah, just keep in mind that I'll let you guys know.
Today, as you guys talked
in
about,
addition
there
to
is
these
a chance,
guys.
and if we don't send
Again,
the booster
I'm
back,
just like
we'll
you.
do a
I'm here to
landing
watch
burn
it,
and a
but also
splashdown
at the
in
same
Gulf,
time hosting
and
it.
then that's just
So
another
yes, so
landing
just in
burn
case
to
that the booster
gather
doesn't
more
actually
data,
make
learn
it
more
back, or
lessons from,
it doesn't
and
have
then
the
we'll come back
manual
and try to catch again on the next
instruction
one.
to go ahead,
But,
then basically it
as
would
of right
land
now,
in the Gulf of
we're coming up
Mexico
on 5
and
minutes.
land in the water.
There is a chance that we'll hold or extend into the end of our window, so don't be surprised if that ends up happening. But if those boats do get out of the way, we are just about 5 minutes away from launch. So I'll check back in just a moment, but back over to you, Kate and Jesse.
Thanks, Dan. Our rapid iterative development approach has been the basis for all of SpaceX's major innovative advancements, including Falcon, Dragon, and Starlink. Today, we're testing hardware and systems, and we need to know how they perform under the most extreme conditions. We'd much rather find the bugs now during testing than later on when there's more on the line. And to reiterate, while we do determine an acceptable level of technical risk on our vehicle and pad in order to learn as fast as possible, we accept no compromises when it comes to the safety of the public or our team. So that is to say, this is only the 5th of many future flight tests of Starship before it becomes fully operational.
You might remember the Starlink panels that are incorporated into Starship, and you can see them there on your screen, those rectangular panels on Starship's nose cone. Starlink brings us the epic views in space and on re-entry, and also helps deliver us the critical flight data engineers need to continue development. In addition to enabling our rapid iteration on Starship, Starlink is also enabling life-saving communication here on Earth. SpaceX is sending tens of thousands of Starlink kits in response to Hurricanes Helene and Milton, and providing free service through the end of the year to support recovery efforts. The Starlink team also worked with T-Mobile to activate our direct-to-cell satellites to provide basic texting on T-Mobile and emergency alerts for all phones and carriers of those in affected areas. If a phone connects to a Starlink satellite, it will have 1 to 2 bars of signal and show T-Mobile SpaceX in the network name. SpaceX's direct-to-cell constellation has not been fully deployed, so these services are being delivered on a best-effort basis.
Starlink is enabling life-saving communication here on Earth and continues to help us push the limits in space. In the short term, by providing great views and real-time data on our next few flights, particularly through re-entry, which historically is a blackout period for all communications.
Okay, it looks like it.
So we're coming up on 2 minutes, 30 seconds away from launch. We were hearing like there was a pretty good chance we were going to hold at T-minus 40 seconds, but surprise, now it sounds like we might not be. So
we'll go.
We are just a little over 2 minutes away, so a couple more things going to be happening.
2 minutes away.
We did just close out our propellant load on the ship and the booster, so 10 million pounds of propellant on that vehicle on the pad here at Starbase, getting ready to go. We're going to start
close out means that it's all fueled up and ready to go.
The lines that are basically pushing all of that propellant to the vehicles, those get cleaned out or cleared out.
And there is now 1.4 million people who are now watching this live stream, including us.
Vehicle, the thrust vector,
so that's quite a significant amount of people who are actually watching this live stream.
We're going to use to steer it.
That's it. If you want to know the live stream count, it's down in the bottom left-hand corner of your screen.
Final alignment,
just opposite from my head.
Our final checkouts.
Other side.
But
that way.
We are starting to hear that it looks like the range is going to be clear at our liftoff time of 7:25 a.m. Central, 12:25 UTC.
That is a magnificent view underneath.
That puts
you wouldn't want to be standing there, which is why it's good to have a camera there instead.
Still not tracking any technical issues. That range clear is the only thing that's been potentially poking at our launch. So I'm going to start to quiet down. We'll hear our flight director for today, Tristan Pierce, give some of the final call-outs. As of right now, we are 1 minute away from liftoff.
So if the range is not ready, it will hold at T-minus 40 seconds. Listening for any additional call-outs. That normally means that they're ready to go. We're past the T-minus 40 seconds. We're about to go.
Flight directors go for launch.
And we'll go for launch. There you go. This is going to be exciting.
Best words you could possibly hear, 20 seconds away from liftoff.
Here we go. 8.
T-minus
Don't
5,
need to.
4, 3,
Here we go.
2, 1.
Oh.
We have liftoff.
Oh, it has lifted off. There it goes.
Vehicles pitching downrange.
On your left-hand side of your screen, all those white circles are the engines. They're all engaged and it is lifting. The Super Heavy booster is lifting. All 33 engines are fully engaged. She is go, go, go.
Phenomenal.
Speed is now 530 kilometers an hour
30
and
seconds
climbing.
into the flight, the rumble's just starting to reach us here at launch control.
Oh, that sound.
Booster and ship,
That
avionics
is
power,
the
telemetry
sound
nominal.
of 33 Raptor engines.
And everything, the call out was, everything is still nominal. We're about to find out whether or not they're going to try and catch the
Max
booster.
Q.
Now pass through the maximum aerodynamic pressure, the most stress the vehicle's going to see on the way uphill.
Max Q is also where they thrust down slightly, so that way the ship doesn't break up in its entirety.
All right, our next
part of
major
the thrust
milestone
bucket.
coming up, it's going to be hot staging. We're going to see the engines ignite on ship to push it
Here we
away
go.
from the booster.
Completely and utterly successful. And she's moving. Absolutely glorious to look at. Coming up on
All
hot
right,
stage.
so hot staging is going to be the next thing coming up. First, we're going to see the booster's engines start to shut down.
Here we go.
All but 3.
So again, look at the
We're going to do
circles
what's called most
on the
engines
left-hand
cut
side of the
off
screen.
instead of main engine cut
That'll
off.
give you a
This 3
live
are gonna
view.
Keep going, and then we're going to see the engines on ship ignite.
When you see the engines on ship ignite, you'll see a plume
Right
around
now,
the midsection.
the tower team is doing their go, no go.
Waiting for tower team.
And we might hear some really good words soon, too. All right.
Waiting for the engines to shut down. Again, the left-hand
Still
side.
see it up behind me.
Those
That is
circles.
one of the most gorgeous things I've ever seen in my entire life.
Booster
Coming up
engine
on
cut off.
hot staging next.
Here we go. We're up for
Ship
hot
engine
stage.
start up.
Most engines cut off.
Hot
Stage
stage.
separation. Booster
Stage
separation.
separation.
Start up.
Hot stage separation confirmed. Ship under its own power. I'm seeing 6 out of 6 Raptors lit. Hopefully I got a booster on the way back to me. I'm going to send it to you guys in Hawthorne.
Oh man, that was absolutely incredible. I loved how the crowd
Chamber pressure is nominal.
here in Hawthorne all went ooh at that first view of the blue flames from the booster. As you can see
Here we
there,
go.
first stage currently performing, or excuse me, is now making its way back to the launch site. Again, we are
Ship avionics power and telemetry nominal.
the booster and the tower are both performing automated checks to make sure we are go for the booster to return to the launch pad for that catch. And once those are complete, the flight director.
Booster boost back burn shut down.
Okay, the booster is shut down. That means it's
Booster
coasting.
return.
And we did hear that the tower is go for
Tower is
catch.
go.
So that was one of the big criteria we were looking for.
Okay. Raw Bogan, yes, they're absolutely going to try and catch. I just noticed your question there. So thank you very much for that question. Yes, they're going to try and catch it. Just let me have a look.
Beautiful view here.
Yes, they're absolutely going to try and catch. Beautiful views.
And so exciting to hear that
through.
We got a go for booster catch. That means it's going to be a really exciting morning. Again, the booster is making its way back towards
They're going to attempt the
land,
catch.
in order to make that catch attempt in the tower.
What you're looking at there, that
so
is the booster.
So incredible to see these views. You can see the ship on the right-hand side of your screen. All 6 Raptor engines are under full power. Once again, the booster is making its way back to the launch site. We are going to try and catch it using the chopsticks on the launch tower, the exact same tower that it just launched from just, 5 minutes ago.
Here we go. So she's starting to come down.
On nominal
guys,
trajectory.
I can confirm the command was sent for the booster to come back.
That is incredible.
So that thing down the bottom of the screen, you can see there. If you can see, yes, that there,
right
that is the staging ring that's falling ahead of it.
I can't wait for us to hear the sonic boom through Dan's mic.
Right.
That is going to be incredible. It was so cool to
We're
hear the
coming in.
liftoff. And so once again, a successful on-time liftoff of Starship Flight 5. The ship has separated from the booster. The booster is there on your screen. It is making its way back to the launch site. We are going to attempt the catch using the chopsticks. We did hear the confirmation that the command was sent to the tower. We are go for catch.
Okay, you'll notice there's no entry burn.
Just be about 30 seconds away from our landing burn. It's going to happen in 3 phases. We're going to land at 13 engines burn.
Here it comes. They're giving a close-up view.
See it coming down
Here
through
it
the
comes.
plume.
Booster coming in hot for booster catch.
2,200 kilometers per hour.
13 of those Raptor
Glowing at the
engines, and
bottom.
This view is incredible right now.
There was no entry burn. This is coming in. There is some heat
See
shielding.
how fast this vehicle is moving on the left hand.
It's lit. She's coming in. Here we go.
13 ignited. We're now down to 3 Raptor
Okay,
engines.
this is for control
You
authority.
can see those chopsticks now
Chopsticks are in. It's coming back. It's a little off. It's trying to control. Oh my God! Oh! Oh, they got it! I've got goosebumps! Oh, they got it! Whoa! They got it!
This is absolutely insane. On the first ever attempt, we have successfully caught the Super Heavy booster back at the launch tower.
Blasting your eardrums. Oh my God, they did it. They absolutely did it. I've got goosebumps from that. My hairs are standing on end on my arms and my
Dan,
legs. They got
I
it.
don't know about you, but we're
I was
losing
waiting
our
for the
stuff
last
here.
moment for it to be lost, but they got it.
I'm sorry, like, even at this day and age, what we just saw, that looked like magic. Oh, wow.
Still on fire at the base of it. Oh wow! I don't know about you guys, but wow, that was amazing.
Folks, this is a day
Oh, they got
for
it.
the engineering history books.
They got it. Oh, they're gonna do it. Oh, they're gonna
This
do
is
all
a
of it.
live view of the Super Heavy booster as it has just been successfully caught
Oh, they're gonna
back
do all
at
of it.
the very same launch tower that it just came from. Dan, I love this. You
Yeah,
are
I'm crying.
reflecting
Yeah.
exactly what
I'm
everybody
happy
else
and-
here in
oh my
Hawthorne, except maybe a little bit more because you got to see it
Wow.
with your own eyes.
How was that?
We got it. I mean, like,
Absolutely stunning images, quite correct. And yes, awesome. It's look at it. It's just hanging there.
Main engine cut off, ships in orbit, but I am like shaking right now. That was
Okay, you can see this little spot here on the screen that's moving around. That was a drone in midair. So there'll be some spectacular landing images.
Starship nominal orbit insertion.
And Starship is in orbit.
Exciting news there. It's hard to believe that booster isn't the only excitement that we have today. Just confirmation there.
It was possible after IFT 3. That's after IFT 4. It's definitely possible.
And it is now
because now they're going to be using it rapidly.
This is just an incredible day. Live views there as the booster vents.
Oh wow! Look at those stunning
that is
images
a live view
on the
from the
right-hand
top of
side
the tower, looking at the chopsticks.
I am still in disbelief. I'm trying to catch my tears, just like the chopsticks top the booster.
Wow!
It has been nonstop since liftoff.
Wow!
We are all so excited about everything that's been happening so far this morning. With the booster having completed its job for today, we are going to take a short break for the next 30 minutes. We'll return back at T plus 40 minutes while the ship continues to coast before re-entry.
Oh, man. And as with previous flights, Starlink may actually enable us to talk with the ship through re-entry with no communication blackout. We, of course, are still testing Starlink during this phase of flight, so nothing is certain. But if we do have views, we'll be sure to bring those to you live.
Views or no views, we'll see you back here at T plus 40 minutes for coverage of Starship's re-entry, flip maneuver, landing burn, and splashdown.
Yeah, guys. Now's time for questions and answers. Yeah, that was absolutely amazing. I saw it, you saw it, we all saw it. That was absolutely stunning. Yeah, SpaceX just made history. Again, they're the first to actually land a Falcon 9 back on land in 2015. Now they've successfully managed to catch a booster, a huge booster. And Starship here is just happily cruising through space. If you want to ask some questions, please do. That was absolutely amazing. I'm going to have to mute myself for a second here. Sorry, guys. Had to grab a drink of water as well. Absolutely amazing. SpaceX has made history again for the upteenth time. They successfully just caught the Super Heavy booster. If you didn't see that earlier, yes, they've just caught the Super Heavy booster. It will return to the launch pad. They caught it via using Mechazilla. So everything that SpaceX was claiming that they were able to do, they have certainly now done. It's been absolutely amazing. I am still going to be here. If you want to continue to be with me, please feel free to do so. If you, like me, you've still trying to come down off cloud 9, yeah, this might take a while. Yeah, it is 10:37 at night. I don't think I'll be sleeping very much at all, to be perfectly honest. If you want to have a chat with me, please feel free to do so. The comments are still open. Please, I'll send out the welcome message again just to remind you guys that I'm here. Starship is cruising at 177 kilometers high and is traveling at 26,000 kilometers per hour, which is orbital velocity. It is done successfully. It's done beautifully. The images on the left, no, they're not practicing. They're not trying to do anything. They actually caught the Super Heavy booster on the tower. They have managed to do it. It has just been absolutely magnificent. I've brought it to you guys. I'm so glad I could bring it to you guys. Yeah, just remember, the chat is still open. If you want to ask any questions, please feel free to do so. The next part will be coming up in the next 30 minutes or so. Once everybody's managed to gather their thoughts together, they'll... Yeah. Wow. Look, I'm going to, because there's no one making any comments, I'm just going to play with my, I do actually have applause, and yes, there is definitely applause to SpaceX, and yes, definitely a cheer for that to actually for them to do that. So yes, absolutely amazing. And there it is, sitting right there. That's the super heavy booster they just caught. That's been boosted, the Starship, which is there. They just managed to catch it back in the Mechazilla's arms. Again, making history, forwarding the human race through rapid reusability of space flight and rockets and rocket engines. And so all of a sudden the launching something to Mars in 2026 is completely and totally and utterly possible. And yeah. Oh, yeah, that was wild. That was wild. The same sensation I had 9 years ago when they landed the Falcon 9 booster, first stage back on Earth in 2015. Would have been about December, so it's almost 9 years ago exactly. So yeah, the first time that I actually landed. I'm just going to mute myself. I'm going to work here in the background for a second or two and see if I can get some of those, replay some of those images for you, if possible. If not, then I'll just be ready to stay here. I'm still here with you, watching this. Bringing this to you. Starship will end up going through its orbit, and then it'll come back and it will land in the ocean, the Indian Ocean, off the coast of Western Australia. Again, they're looking to use aluminium tiles, not aluminum. Aluminium tiles. Us Aussies say it that way. And yeah, they're to actually test the different regimes in terms of how they heat on re-entry. So there's still a lot more to come. I'm sure SpaceX is celebrating like everyone. And yeah. Oh, God. Wow. Just a sip of the special stuff. I bit parched. I screamed a little. Celebration. Yeah, amazing stuff. Amazing stuff. Just absolutely amazing. Yeah, it was highly successful. It worked completely, totally and utterly. The images you're seeing now on screen are actually from the Starship as it cruises through 202 kilometers, at 26,000 kilometers per hour at an orbital velocity. The Super Heavy booster, just for recap, was actually caught in the Mechazilla, so the large pair of arms that, I've forgotten what I was going to do. I'm now just talking to you guys. So if anybody's still there and they want to have a chat, please, reach out and have a chat. I'm quite happy for you to do so. The chat is still open. If you are still there, it's me, Margaret. Oh dear. Yep. Okay. Once again, back. I just had a little bit of. I managed to spill water all over my desk, so I'm currently. There's water all over my legs where I kind of knocked it a little bit. So what I'll do is I'll just change this aspect ratio a little bit better, so that way you see more of Starship cruising around. We'll get into the questions and answers in a second. So that way you actually get more of Starship, more of the things we all love, because just remember I love seeing that on screen right next to me there. So I'll just, whoopsie daisy. Well, there you go. That wasn't something we were expecting, was it? All right. There we go. Reduce me down. Bring this out. Bring this puppy out. There we go. Awesome. Yes, it was, Jim. It was absolutely awesome, without a shadow of a doubt. It was absolutely amazing, and it was interesting. It's so I had goosebumps, mate. I don't know if you did, but really had goosebumps. It was completely. Yeah. So what did we just witness? We just witnessed what Rob Hogan has just said. This is the greatest engineering achievement in history. Yeah, it would be. This makes us officially a multi-planetary species as of today. It's no longer being talked about as in a possibility that might happen in the future. The future is now, Rob Hogan. Absolutely, 100%. We are now a space-faring species. We are able to go beyond our own, beyond Earth's gravitational well and out into the stars. And SpaceX has certainly led the way with which to do that. A lot of other companies have actually proposed it in the past, have tried to do it in the past. And in terms of reusability, there was a space shuttle. There were the Apollo missions weren't exactly very good at that, but. Yes, absolutely. This is the first time we've become a spacefaring species. And it's all thanks to SpaceX. You can say what you like about Elon Musk, but you don't bet against Elon Musk. It would be a shame that with any changes that are coming up in the US presidential elections, if there are any, let's hope that he is still able to do what he needs to do. Let's see what happens with the tiles on re-entry. Yes, absolutely, Joe. Joe, mate, yeah, absolutely. Want to see what happens with these tiles. I'm quite keen to see what's going on. So apparently everybody was been replying to me, but things haven't been going out. Something was going wrong with it. So the Eagle has landed. Absolutely, yes. Oh, yes, you actually, yeah, you might be right. It is a large engineering feat, but yes, we did land on the moon. I forgot about that. I forgot about that. Oh, there you go. There's something you won't hear every day from Space Nuts. Yes. Can't speak. Me too. I couldn't speak for hide your wished. It might have been one small step for Neil, but it was a big one for me. Yes, I missed that by a few short years, missed seeing the Neil Armstrong landing on the moon. The astronauts landing on the moon with Neil Armstrong actually stepping off on a different on our moon. That was, yeah. But the difference between that and this is rapid reusability. They're able to now catch the boosters. So this will mean, don't get me wrong, they're able to do it successfully today. This does not mean that they'll be able to do it every single time without fail. I am sure that they will fail. They will get it wrong, and things will change, because that's what SpaceX does. They learn fast and move forward. So that way they always rapidly reiterating, which is some of the primes don't actually do any longer. So yes, I apologize, guys, that if my messages weren't coming out. I was pressing buttons and things weren't working for a little while there. I think having a little bit of problems getting things through, just because there's now 2.6 million people watching this live stream, not this live stream, but SpaceX's live stream. So nice Scottish reference there. Absolutely. Whoopee. Yeah. Hide your wished. Is that what you meant? Is that what the Scottish reference is? Jim, you're going to have to teach me all these things. So yes, you might have to educate all of us and explain exactly what the wished is. So thank you very much for continuing to be here, guys. I do appreciate it. And if you have any more questions or anything, or any comments you want to make about it, yes, it's a marvelous engineering feat, and it's a marvelous engineering feat now for the 20th. We should be quiet. No, I can't be quiet. I just can't be quiet at all. Not at all. Not after that. Yeah, not after that. So it's almost 11 p.m. here in Queensland, Australia. So yes, it is starting to move towards midnight. Just checking to make sure everything is still working. There are quite a few people watching who are not commenting. So hi guys, if you want to watch and comment, please feel free to do so. The questions and answers are open, and I'm going to be following this all the way through to see what happens with the heat tiles in regard to Starship, and see if there's any differences between the IFT4 and IFT5, which this one is. IFT stands for Integrated Flight Test. So that's the booster and Starship being integrated together. So it's an Integrated Flight Test, IFT. All right, so 25 minutes into it. It's all no more images of the landed Super Heavy booster so far. Nothing is coming through just yet. So yes, in case you missed it, the Super Heavy booster was caught, returned to the launch pad, was caught between those two massive arms called Mechazilla, and it has changed the course of history as it is now. I always thought that they would, but I'm really glad it's actually happened. That was incredible coverage of an incredible mission. Looking forward to the outcome. Yes, well, I think we're all looking forward to the outcome. I think I'm looking forward more... looking forward more? What more am I looking forward to? With this tower that's been built, it's fantastic. It's absolutely amazing. With the second tower that we've seen there, that they've got in the background, and they're looking to rapidly reiterate as many Starships and Super Heavy boosters as they can. And they've already caught this one, so they don't need to reiterate that. They might actually scrap it. We don't know. There might be a better version of it sitting there ready to go, because SpaceX has rapidly reiterated all of its designs and now has managed to do that as well with Starship and the Super Heavy booster. So I imagine that what will happen between now and 2026, anytime during 2026, in Elon's optimistic timeline, will be that I'm sure they will test a lot more. The only thing that will stand in the way of any future tests or anything like that will be the FAA, which is the Federal Aviation Administration. They are the ones who restricted the launch license for SpaceX, and that was because they needed to do an additional environmental assessment to make sure that, because SpaceX had changed the parameters from actually putting the Super Heavy booster, doing a soft landing in the ocean, to catching it in back at the launch tower. So there needed to be an additional environmental assessment that needed to be carried out before the FAA granted the launch license. And the launch license was only granted a few short days ago. So so in terms of this, I was a little bit unprepared, and with that, which meant that I was caught a little bit off guard, because I thought that'll take them a couple of weeks. I didn't really quite realise that they'd be doing it right away. But then again, it's one of those things I should keep myself. I underestimated Elon and the team at SpaceX, and I really shouldn't have done that. That's me. All right, so yes, the next things that will happen is with this particular live stream, I'm still going to be here until we manage to get to the next part, which will be making sure that I cover the landing of the Starship, which is currently cruising at the moment. It will land in the Indian Ocean, which will be off the coast of Western Australia. Currently, at the moment, you can see that there's images, live images being presented of the fin on the actual side of Starship. If we have a good look here, you can see there's additional protection here, and that additional protection was where in IFT4 the Starship managed to burn through that layer with its control flap. and when it was coming back in IFT4. It did actually hold on, and it did actually manage to do the maneuvers quite successfully, which meant that the whole IFT4 was successful. Now, in orbit transfer of propellant, I'm not sure if they're currently doing that at the moment. There's no further word just yet. But if you have a look, the two down here towards the bottom of this side of the screen, you'll see there's LOX and CH4, which is liquid oxygen and liquid methane. They're going to use to actually do any flips and turns, and then soft landings into the Indian Ocean. Again, there it is there. That burnt through last time on IFT4. They possibly put in some additional thermal protection to make sure that it doesn't burn through the control flaps, so that way they can actually test things a little bit better. You also notice on the control surface there isn't very many tiles on the top of the control surface, just simply because the vast majority of the heating will happen underneath this as Starship belly flops through. All right, coming back to questions and answers. Jim, again. Oh, hey, Joe. Say hello to Saturn V for me. Me too, mate. Me too. Make sure you say hello to the Saturn V for us as well. All right. So, again, historic evening for me, or day for start to day for some others, which would be Sunday. And thank you very much all for coming in and following along and having a look and following this particular live stream. I do really appreciate you being here as always. We are Space Fam, and thank you very much, you guys, for joining me. If you want a more comprehensive view, again, I'll go back and say go and follow the Everyday Astronaut. He's probably going out of his mind and going through a lot of the footage of exactly what happened. I'm unable to do that here, I don't think. So yeah, it's just going to be the live stream of me talking all over the top of it. Just while there's nothing happening at the moment. So the other thing is too, there is also NASA Spaceflight. They'll have, if you want to go and start up a separate live stream, NASA Spaceflight, those guys down there at Boca Chica in Texas, down at Starbase, they will have more of a live view of the caught Super Heavy booster, so they should have a bit more of a live stream about that. The last images I saw on SpaceX's official live stream here was that the booster was settled and the propellant had finished venting, and the small fire that was at the base from the landing propulsion when it was propulsively landing, it had gone out, so that means it wasn't actually a major fire at all. So absolutely fantastic news. Wonderful to be living in the 21st century, I tell you. I tell you. Anyway, so yes, in the next points will be SpaceX is looking to send a Starship to Mars in 2026, and they'll possibly be sending a whole fleet of them. They have a integrated factory. Everything is vertically integrated, as I said at the beginning of their live stream, and they can actually produce many Starships and many super heavy boosters. Even though they will lose oh, there it is there. It's still sitting there, absolutely hanging there. That's the caught super heavy booster, and absolutely looking fantastic. So the cloud you can see there in that particular image at the base there, that is they're venting the liquid oxygen or the liquid methane, just because the tanks may have overpressurized, or they're just getting rid of if the tanks are overpressurized, or they're just getting rid of the excess that were in the lines and bleeding that out into the atmosphere. All right, and that's what's happening there. So once again, I'm just going to take a small break here. I'm going to put myself on mute. I'm going to have some more water because I've managed to once again talk myself hoarse. But again, if you want to go and see something more comprehensive, or you would actually, even if you'd like to see this in Spanish, or you need a Spanish translation, Cristiano Bendeo, Astro Animator VFX, he is doing this in Spanish. So he's still going at the moment, or he has decided to end his live stream. So yes, I appreciate you being here on Aussienaut to join me for this. And look, if you just remember, as a reminder, that you got to like and subscribe and do all those wonderful things. Share it around if you like this. An Aussie rambling on this. Please like, subscribe, do all those wonderful things. If you want to support me on Patreon, please feel free to do so. It's patreon.com/Aussienaut. There is a merchandise store as well. the merchandise. Sorry, I didn't mean to click my tongue in the middle of that. Anyway, yeah, there is. Sorry, I just got distracted. If you can see here, that's the moon. That's moonrise for Starship. Oh, wow. Oh. Hang on just a minute. Okay, wow. You can clearly see the moon in that previous image. Anyway. All right. Yeah, so if you... where was I up to? I can't even remember. There's so many dramatic images that I've seen during this live stream. It's been SpaceX live stream. It's been quite stunning what we've seen, what they've presented. So yeah, this is a drone view of the Super Heavy booster that's just been caught. They're upping the flaps, so you're not going to be able to see the moon, and it just got cut off. There's a lot of debris coming off it. It's either loose tiles, or it could be debris, something has burnt off, or it could be chunks of ice. It's not looking like the right color for ice at this stage. Not quite sure what that is. If anybody has any ideas, please have a chat in the comments. So yeah, so like and subscribe, support me on Patreon if you want to independently sponsor me to do more of this sort of stuff, because yes, I do random things like live stream launches here in Australia. I do talk to people in the Australian space industry. That's the whole point of the channel. I focus on the Australian space industry exclusively, which is how Aussienaut exists. That looks to be chunks of ice now. Yeah, I think there's chunks of ice from the from outside the tank. Bit concerning that there are tiles missing. Just here. Yes, there's also merchandise if you want to go along and purchase some merchandise. There's website aussienaut.com, and then there's aussienaut.com/store where you can go and purchase some interesting merchandise like this here, which is the RESAT mug. The RESAT was launched as a weapons research establishment satellite. Nothing complex, just that's what it stood for. And this received permission from the Australian Department of Defence to actually reproduce this image here of the logo that was used in 1967 for the RESAT satellite. The RESAT satellite was Australia's first attempt at putting something into orbit. It was a satellite that went to low Earth orbit and remained there for quite a while. It launched on a Redstone rocket, which was actually a ballistic missile, and was provided by the United States from a little place in South Australia called Woomera. So basically, again, somewhere in the middle of nowhere. If you want to know, Woomera no longer has any launch facilities available. However, now it's because it's a testing range mainly for weapons by the Australian Defence Force, Australian, US, UK Defence Forces. A lot of weapons are still actually tested there. So now there is Southern Launch, which I'm representing here, and they have the Kunaba test range, which I was at for the high impulse launch. So yeah, if you want to come along and sponsor me for that sort of stuff or support me, then please follow along, like, subscribe, do all those wonderful things. And yes, I'll be happy. I would be pleased. I'll be really beside myself with happiness if someone manages to do that. I do have a couple of supporters there, so thank you very much to those guys who are supporting me so far. But yes, and there's a lot of other things. I suppose I should actually explain myself as well. The live streams haven't been forthcoming a little bit. just because I have been extremely busy with work. That's beside the point. But yes, I've also been working on a number of different things in the background, which hopefully I will get to release to you guys shortly. Well, sooner rather than later. But yeah, it's just remember there is only one person in Aussienaut, and that is me, and that's about it, and that's all there is. All right, time for me to take a break.
Welcome back to Starship's 5th flight test. It has been an exciting day so far. Even the crowd here is still so excited. We lifted off from Starbase at 7:25 a.m. Central Time. The Super Heavy booster and ship had a successful separation, as well as a good boost back burn and good separation of the hot stage adapter. The Super Heavy booster then completed the landing burn with 13 Raptor engines igniting and slowing down the vehicle perfectly for Mechazilla to catch the Super Heavy booster for the first ever land recovery of the vehicle.
Now, it is insane to think that we're not done yet. We still have, in about 48 minutes, the ship will re-enter. The flap, all the flaps that will today, not that could. The ship will re-enter the Earth's atmosphere. Now, as a reminder, one of the main goals of today's test flight is for the ship to make it through the extreme heat of re-entry and to do so in a controlled manner. We learned a lot about this phase during Flight 4 and, as a result, completely reworked the heat shield, but more on all that in just a minute. Now, re-entry is typically a portion of flight where we don't have communications with the spacecraft because re-entering, it'll be re-entering at about 8 kilometers per second, or about 5 miles per second of roughly orbital velocity. Now, those speeds, the spacecraft moving through the atmosphere results in friction and creates a plasma field around the vehicle. We saw this in action on Flight 4 thanks to Starlink, and wow, it was breathtaking. The blanket of plasma ends up distorting communication frequencies, so it's not uncommon to experience brief blackouts in communication, but hopefully that's not the case today.
And Kate, that's where Starlink has just kind of been just the unsung hero and the MVP of this test campaign. I mean, it's able to give us data, not just awesome video, but also data in real time as we're going through reentry. I mean, this is something that throughout the history of spaceflight just hasn't been possible. And this is an environment that is so unforgiving, so hard to model, so hard to understand. And for the first time ever, we're able to literally watch as it unfolds in real time, get that data in real time. And we're able to do that with Starlink. And it's great for us because we get to see something. We get to see the greatest light show on the planet or off the planet. But what it means for this program, we're able to learn tremendous amounts about our heat shield, our angle of attack, everything that we're doing as we're coming in through the atmosphere at hypersonic speeds. And it's, you can't just thank it enough. And also special shout out, you're going to see some additional flap camera views. We've got a really amazing team of avionics, cameras, electronics, software people who made all that possible. And so hopefully they're going to give us an even better show on the way in today, as we're coming in at about 5 times the speed of sound.
Yeah, those flaps, Dan, that you see there, that's what's helping.
Starship is in a good attitude for entry, approaching the entry interface.
And some good call-outs there, preparing for re-entry for Starship. And again, that's what Dan was mentioning, those flaps on the vehicle.
Coming up on
and
re-entry.
If you've been watching us for
the
last few minutes, you could see that the flaps were rotating around and helping orient the vehicle as it prepares for the beginning of re-entry today.
Yeah, exactly. Re-entry will be enabled by that heat shield that you see on the bottom half. That heat shield is made up of 18,000 hexagonal ceramic tiles, and they are designed to insulate the vehicle during atmospheric entry. At that point in time, temperatures can be as high as 26,000 degrees Fahrenheit or about 1,400 degrees Celsius. The design itself also permits for rapid reuse with no refurbishment between the flights. And fun fact that I think is just incredible in terms of scale, but the heat shield alone on the ship has a total mass of 10.5 tons, which is crazy because these things are really lightweight. They're made out of ceramic. We have a couple of them here. The one that I'm holding is used on flat surfaces, as let's see if we go that way, because as it's flat. The one that Jesse has is kind of more what you see there on the side.
Yeah, exactly. And having these different shapes, the flat version and the curved version, allow us to cover a lot more of the surface area of the vehicle. Again, we need to protect every portion of it. So even those curved surfaces, and especially the hinge area, if you watch Flight 4, is really what we want to make sure that we protect. And yeah, Kate, these are very, very lightweight.
But when you put 18,000 of them together, they add up to 10.5 tons, which is incredible. Now, we did mention earlier that the heat shield has been completely reworked.
Starship has entered the atmosphere, remains on a nominal entry trajectory.
We can start to see that plasma now starting to build up on the side. It's not quite full plasma yet, but we are starting to see that.
This is where it starts getting exciting.
That the heat is building up on the heat shield.
Not sure what you meant by that, Raw Bogan.
Cool
sorry, mate.
Really
no idea.
Never really have gotten to see this
might have been
live
something
before,
else. It might have been a different island.
Before Flight 4.
Yes, I need a safety helmet on, ready for splashdown. We'll go back to the beginning image.
There on your screen, that means that heat is building up, but that's exactly what these heat shield tiles are there for, is to protect against this plasma and this really extreme heat that the vehicle is going to see for about the next 10 more minutes or so.
Yeah, so the ship will attempt to light the 3 center Raptor engines, and those are the engines that can gimbal or maneuver or point, and they do that to help flip the ship until the engines point down so that it can land using the Raptor's thrust in the ocean. So that will happen after we get through this re-entry period. Again, now starting to see, and we also might start to see the flaps actuate a little bit here as the vehicle controls its roll during re-entry. That was one of the main learning points from Flight 3, was the roll control didn't work quite as well as we wanted it to. We learned that we needed some redundancies, so we added more roll control thrusters, and we'll see those in action as well today, as that was a Flight 3 learning that worked better on Flight 4 and still enabling that same design today.
Oh, look at that.
Starship has passed through 85 kilometers altitude. Flaps now have control of the vehicle.
Great call out, as Kate mentioned, the flaps are controlling the attitude of the vehicle. And I love these views because it looks so calm everything is relative, right? So relative to this camera on the ship, it looks so calm
So
and smooth.
calm.
The vehicle
Quite
is
right.
traveling extremely fast. You can see the speed on the bottom right-hand corner of your screen.
26,000 kilometers per hour.
Mars, where there are no runways or other humans to
Mach
help
25.
out. So we also want rapid reusability. So we're doing propulsive landing instead of a more traditional means like parachutes. And so we will use the engines on this vehicle to help slow the vehicle down for a vertical landing.
Yeah. Now, entry is going to basically happen in 5 phases. The first is low drag. That lasts for about 3 minutes.
Mach 21,
Next is
sorry.
high heating, and that beginning
when
heating increases above the heat rate breakup limit. That lasts for about 10
Gorgeous
minutes.
images.
We then have high dynamic pressure. Starship will continue to slow down and experience increased aerodynamic loads during that phase, and that will happen before reaching Mach 1, about a minute after.
Starship is approaching the peak heating phase of entry, remains on a nominal trajectory.
Okay, so that was phase 2 that he just called out, that I was mentioning. After peak heating is that dynamic pressure around Mach 1, and that will last about a minute after leaving the hypersonic area, and then we go into subsonic, and then, of course, landing burn. Wow, what an incredible view.
The colors are so amazing, and the colors actually also tell you a little bit about the temperature that the vehicle is seeing as well. So I think that's pretty cool that we get this amazing live visual.
Speaking of live visual, the flap, we have more views, more cameras
excellent.
on board Starship,
flap.
as Dan mentioned a few minutes ago.
We'll see whether or not that survives this time.
That all 4 flaps will stay more intact than they did last time. We did make some changes to the design in order to help enable
Starship
this.
is now experiencing peak heating, remains on a nominal entry trajectory.
Okay, that heating is from the compression of the atmosphere in front of.
Along the path that we intended it to fly.
There we go. There's the stream out the back.
Track with how fast it's going.
It seems to be
and
losing
how high it is above Earth.
Parts of the heat shield. I'm not sure if that heat shield is meant to be ablative. Ablative means that it flakes off to actually take the heat away.
Guys, this is where we're really going to see a lot of those improvements from Flight 4 really come into action. As you guys kind of talked about, so it's called the static arrow. Those are kind of the poke out points on the flaps. Those get exposed to some pretty extreme heat environments, and so we added some additional, basically made it a lot more robust for the thermal protection there. And we learned not just from visuals and stuff like that. We had those missing tile tests on Flight 4 where we intentionally left some out, kept in some backup layers. They're called ablatives, which means they just
they do have
melt away
ablatives
to help dissipate the heat. And we've got an entire layer of ablative underneath the tiles on this Starship today. So even if you get a gap in a tile or a tile is broken, anything like that, we've got essentially backup options. And what we're really trying to do today is do an on-target landing. As we lost the flaps, you lose a lot of your control, and so we didn't land right on target last flight. This time we're trying to really nail the target within just tens of meters, and that'll just be a really huge step on feeling like we're closer to bringing a ship back. Obviously, there's a lot of work before we get there, but we just caught a booster. We're going to start looking real soon at when we can catch a ship.
And they have every right to be a little bit arrogant about it too.
So the view on your left
confident.
is as a helicopter passes by Dan, bound at Starbase. The view on your left is a camera that's positioned near the nose of the ship, looking basically down toward the flap. The view on the right is looking perpendicular to the flap. So we're looking basically bird's eye view onto the flap.
Based on IFT4, this is still got a long way to go.
From the side,
so it is going to get much, much worse than this. So we were about to see whether or not there's going to be...
just buzzed the tower. He might be coming back, so...
Now, these views brought to us by
here we
Starlink.
go.
It's incredible that we have this high-definition capability. In fact, that view on the left...
Starship is now halfway through the peak heating phase of entry, remains on a good trajectory.
So great news there, hearing that we're about halfway through the peak heating phase, like I said.
So as it comes through, watch this area down here where they put in the extra tiles, because this is what started to go through, burn through, or
it is incredible that we've basically
degrade as it went through.
Entire time
went through, re-entering the atmosphere.
My memory did black out a little bit after booster catch, so I think we had views. But all through the coast phase, we had some beautiful views of planet Earth behind the ship as it was in its orbit.
Yeah, and I also do want to point out on your right-hand screen, we've got a more encompassed view of the flap. As we watched in Flight 4, the hinge area was the area where we got a little bit of that burn through. This view, this new camera view on the ship will help us be able to visually see more of what's happening in that area. And again, we have improved our heating tiles, and so hopefully we've protected the hinge a lot better this time.
Landing chill has started.
But again, these views are additional to the data that we get on these flight tests that help enable us kind of put the data that we get in the computer to the visuals that we see and try and align those and use that for improvements in the future.
Now, we heard a call out there saying that engine chill has begun. This is an indication that we are starting to flow a little bit of the super cold liquid oxygen through the hardware, through the Raptor engine, specifically the turbo pumps, to help ensure that the hardware is at the right temperature before we give a full push, a full flow of propellant at engine startup. So all of that to say, we are getting closer to the landing burn.
We definitely are. And again, if you look at the bottom right hand of your screen, you can see the altitude that the ship is, and it has been slowly making its way closer and closer to Earth. We're currently at about 63 kilometers from planet Earth, and you'll see that number trend lower and lower as we get closer and continue through this re-entry.
Yeah.
Can you imagine what this looks like in the ocean when you see this thing screaming over the top of your head?
We have about 10 minutes or so,
blazing
roughly,
for all it's worth,
before we execute the landing, the ignition for the landing burn, starting with the landing flip. So we're making a controlled re-entry. This is one of the primary objectives for Starship today, is to demonstrate another controlled re-entry, even more controlled than what we saw on Flight 4. And so far, that is looking good.
And then as we start to really get lower, we're going to start seeing the atmosphere's effects start to take place, and that's when we'll be dropping our speed down closer to the speed of sound. You'll see the flaps start to maneuver. We were able to do a landing burn on Flight 4, which kind of caught all of us off guard. It was pretty incredible after seeing the flaps survive through. And we're going to try and do another one on this flight today. We tweaked it a little bit, so we're going to try and splash down at a little bit of a gentler angle this time, instead of just kind of hit the water and fall over. And the goal with that is try and keep the ship intact, and then if we're able to then get some additional video of it, again, that's just more data. And everything we can see, everything we can get extra, like a couple extra seconds or minutes of data coming from the ship after
Starship has
splashdown.
passed through the peak heating phase of flight, approaching maximum entry dynamic pressure.
This is where Starship will get nice and toasty.
Heating coming up is basically Max Q Part 2, where we're going to hit kind of that part of the curve.
The tiles have now gone
we're
white
still
hot
moving really fast,
down
and
in
the
this section
atmosphere
here,
is just dense
which
enough
you can
that
see.
we're feeling the most pressure. But hopefully we're going to start feeling a little bit less heat.
It's gone to white hot. So they've given us the image of the two rear flaps.
Like we got more views
and
of each
the
of the
top
flaps
flap.
on the ship as it's making its way back down to Earth.
These two are on the rear. This one is at the top. Top of
And
Starship.
we did pass through peak heating and still got really good views throughout that whole period. Typically during the highest heat on the vehicle, we tend to build up a lot of plasma, and that's typically when we would lose
it looks like
connection,
it's starting to burn through. You can see that starting to happen
but again,
here.
with Starlink, we were able to get some
mouse
live views throughout that entire process there.
and we're coming up. We'll start here in a couple more
Both rear
milestones
flaps
in about
seem to
4
be
minutes or
coming
so,
through relatively
when we start getting
unscathed.
down to like the transonic, the subsonic, when we're starting to move
Again,
closer to and beneath the speed
watch
of
this
sound.
section here. It is just appears to be disintegrating.
I mean, we're getting.
There probably
live views,
they've
we're
probably
getting
done this
live
on
data.
purpose
We've
to
got
actually
a couple
determine
additional tests on this one today,
what it's capable of doing.
We left
if
off some
if
missing
some of it
tiles again
there.
to test some additional backup layers. We also have, I don't know if we can still quite see them in this view, but you may have noticed we had some kind of silvery looking tiles on Starship as well. And those were pretty much standard tiles, but they were wrapped in aluminum. And it was a pretty simplistic, straightforward one where aluminum starts to melt at roughly the same temperature where steel starts to lose its strength, not necessarily melt. And so if we see stuff melting, we know what our steel is going to be exposed to. But yeah, 59 minutes since launch, should be coming up on transonic and everything in just about 3 minutes.
Now the views here, we have coverage of all 4 flaps. We can see, so for those that perhaps didn't catch
there's probably
a glimpse of the vehicle
nearly enough,
before
and it's starting
liftoff,
to
there
burn
are
through
2
just down
flaps
here
at
as
the
well.
forward end and
If
2
you have a good
flaps
look,
at
just
the
there.
aft end. The larger camera view that is there on the right-hand side of your screen, that is a view of one of the aft end or the bottom end flaps. We can start to see some heat buildup and peeking through on one of the flaps there in the top left-hand corner of your screen. Once again, Starship now at T+1 hour and 9 seconds into its flight today, re-entering the Earth's atmosphere.
In this area down here.
Currently about 45 kilometers
away
above
from where
the surface
the
of the
additional
Earth, now 44.
additional
we are targeting a soft
protection they put in.
splashdown in the Indian Ocean.
This is starting to split.
About northwest-ish.
But what that means is,
Australia,
if it starts to
and
split,
we are attempting
it may not
as we did on
fail
Flight
in its
4,
entirety.
Make a perform a flip maneuver as
on
well as
IFT4, it didn't fail. The flap didn't fail; it remained intact.
All right, so that is great news there. Like Dan said earlier, this is basically Max Q Part 2. So this is the greatest amount of aerodynamic loads that the vehicle will experience during its flight. It's coming back through the Earth's atmosphere. It was above the Earth's atmosphere in space where there was no friction. We can obviously see heat as evidence of that friction buildup. The atmosphere is actually helping to slow the vehicle down. If you're watching the telemetry in the bottom right-hand corner of your screen, you can see that speed decelerating rapidly.
And she's through. Still intact. A little bit of burn.
Now the 4 flaps
Absolutely
on
not
the
a problem.
ship help steer the vehicle, and one of the main objectives for the ship today is to demonstrate controlled re-entry during this phase of flight, this re-entry phase.
Yeah, and we have 6 engines on ship, but we only need 3 of them, the 3 sea-level engines. We will have that flip maneuver happen very close to touching down for splashdown. We'll do that flip maneuver, ignite those engines, slow the vehicle down immediately, and then hopefully have what we call
reason why
a
it's
soft
black
splash.
is because it's nighttime on
What
this
we call a
side
soft
of the world.
splashdown in the water.
So, yes,
it's probably going to feel a little bit harder on the top of the surface of the water, but it'll look pretty gentle.
Yeah, and like we said earlier, we hope to have some more views, even of that phase of the flight. So fingers crossed that we can we can bring those to you. We are hoping to splash down softer than we did last time on Flight 4. Right now, Starship continuing to make its descent back
Starship
to planet
is
Earth.
at Mach 2, remains on a good trajectory.
All right, great news there. That tells us that the vehicle is traveling twice is traveling twice the speed of sound. So we will then, the next call out that we'll hear is that it is, traveling about the speed of sound. And then we will hear a call out that that will be the call out that it is transonic. And then we will hear another call out saying that it is subsonic, meaning going slower than the speed of sound.
Flap is actually still controlling.
There it is. So at this
It's controlling the Starship
at this
re-entry.
point in time,
it's coming in
we
as
say
a belly,
transonic
as a belly
because
flop.
certain parts of the vehicle, like the flap
As you
that
can see
you
to
see
the orientation
on your
of
screen,
Starship.
might be experiencing airflow faster than the speed of sound, while other parts of the ship may be experiencing airflow.
Starship is in the subsonic belly flop.
All right, so now the entire vehicle is traveling slower than the speed of sound, so subsonic. The crowd here at Mission Control Hawthorne also getting excited, just like us. We're awaiting a water landing. We are going to reignite the 3 engines
do the
to perform
flip.
that flip maneuver, and
And that will be here. You'll see this because you won't actually see it on screen.
away from the landing flip.
Yeah, the crowd's getting excited here as we get closer and closer to splashdown. Again, just about a minute away from the expected
10K's
splashdown.
up, so it's still
we should
quite a
see
while
a lot happening.
way away. Now down to
coming
9.
up here shortly. We're currently having a view
It'll happen at about
of
2 or 3
flaps,
kilometers.
and it is a little bit dark on your screen, but hopefully we'll get some good views of the ship as it makes that flip maneuver and touchdown for splashdown.
Yeah,
yeah, guys, we saw that speed drop like a rock. So we're doing a belly flip right now, or a belly flop right now. That's what's kind of, if you saw the high altitude campaign, that's the unique thing about how Starship comes back. So we've let off pretty much all of the speed we're going to. We're essentially at terminal velocity.
Starship is at 5 kilometers altitude, remains on target.
Watch here.
5
This will
to
give you the
go.
orientation
Coming up
of
soon, landing
Starship.
burn.
Three kilometers. 2 kilometers.
2 kilometers away.
Starship is on target, approaching landing burn startup.
So
1
keep
kilometer.
an eye on the bottom right-hand side of
I
your
thought it'd be
screen as
sooner than
well.
this.
That will be the indicator when the Raptor engines ignite, if we are unable to see that illumination ourselves.
Landing burn startup.
Oh, okay. Okay. It's happening. It's happening. Oh, look at that.
See the water just behind the ship.
Starship has landed.
An incredible view.
It landed.
I think it is safe to say
It landed.
we have a ship
Here we
in
go.
the water.
Oh, and down. Lost the signal. Oh, there's a ship.
That is a live
Oh.
ocean surface. What an incredible end to Starship's journey. A live
Wow.
from a buoy that we had out at the landing zone.
Wow.
An incredible view of ship landing just about on target as they were calling out.
Moly. Sorry, I shouldn't.
That was
peeking.
amazing. And we were not intending to recover any of the ship's hardware, so that was the best ending that we could have hoped for.
What an accurate landing. They managed to get it right near the buoy. Oh, the buoy. We call him buoy. B-O-U-Y.
Man, I don't think we're going to be able to get a ton of extra video of the heat shield, but we hit the target.
Wow, that is hitting the target.
I mean,
that is incredible.
You know we hit the target because we had these buoys placed in a pretty specific spot, so wow.
That's
what a day.
insane.
I feel like that's what I get to say. What a day. I mean, everything started off today with that launch. We were able to lift off towards the end of our window, 7:25 a.m. Central Time. 33 out of 33 Raptors in the way uphill. Successful hot stage. Booster came back. We watched it come down right behind us. Watched it get caught. And that broke my brain for a while. I'm really happy we
broke your
coast for a
brain.
bit, but First ever booster catch.
Yeah, the explosion.
Major step on the way to rapid
The
reusability.
explosion.
And
Yes,
ship
the explosion.
Gave us one heck of a show, making it through a controlled re-entry this time.
That
Flaps
explosion,
intact,
yeah.
made it down to the water. Hey, starships were meant to fly, and it sure as hell flew today. So,
didn't it? What?
Let's get ready for the next one.
Absolutely amazing.
They were meant to fly, and they were also meant to be caught by Mechazilla.
Yeah.
It's been such an incredible day today. Congratulations to our teammates and to everyone who supported the Starship program. And thank you to all of our future customers for your support. And we'll also like to thank the people of Cameron County,
they got a little
Texas,
Mechazilla in
as well
between
as
them.
the Coast Guard,
Right
the
there.
Federal Aviation Administration, the Government of Mexico, and the Australian Space Agency.
Now be sure to follow SpaceX on X for more updates on today's test flight and, of course, for future Starship news. Today was amazing, but the SpaceX action isn't over yet. Soon, Falcon Heavy will launch NASA's Europa Clipper, and we're also going to be returning Dragon back to Earth with NASA's Crew 8 astronauts. So congratulations again to the SpaceX team. What an amazing launch and an even cooler catch. Thank you for watching, but we're going to leave you with an awesome recap of what has been the most epic day.
Oh, there it is. Oh, look at that. Oh, from the tower. Oh. Oh, wow. Wow, from the tower. Holy moly. There were people watching on the water in front. That streak at the top of that white streak at the top, that was the Starship going. I thought at this point it was all going to fail just because of the angles. Oh. All right. So, yeah. All right. Thank you everyone for watching. I do really appreciate it. Thanks very much for coming along to watch that with me. It was absolutely amazing and it was phenomenal. And I'm glad I got to watch it with all of you. So thank you very much for joining me on Aussienaut. Absolutely amazing, absolutely stunning. They caught it. They caught the super heavy booster. They managed to land Starship in the ocean, and it was an absolutely amazing landing as well, and it was absolutely phenomenal. And guys, thank you very much for joining me. I appreciate it. Don't forget, like, share, subscribe, all that nonsense. Go and visit the merchandise store. Go and get some merch. Aussienaut.com/store. Support me on Patreon if you wish to. Patreon.com/Aussienaut. Guys, I'm so glad. It's almost midnight here in Queensland, and this side of the country. I appreciate you guys. Thank you very much for joining me. It has been a wild. I just can't compute. Thanks, guys. I really, really appreciate it. I really, really appreciate you coming along. Don't forget to, if you want to support me, you know how to do it. You know how to do it all. I really appreciate you all for being here. And once again, remember, as always, stay caffeinated.